Join discord.gg/flat earth and enter a VC check-in room, and someone will come along to VC verify you to get involved with the conversation about our Earth.
Enemy spotted.
ProtoThad.
Alright. I should be good now, my friend. Hopefully you can hear me. I do apologise if I start roboting. If I do start roboting, mate, just tell me and I'll start.
You were at the beginning, but you sound a little better now.
Stunning. Awesome stuff, mate. So, celestial navigation can only work on a globe, apparently.
Yeah, you were breaking up there a little bit then, but I think you were saying celestial navigation will only work on a globe. That's my position. Yes.
Okay. I mean, can you explain to me, for example, how this is done? Because from my understanding, obviously every star has a ground position on the surface of the Earth, and that angle is 90 degrees.
Yeah.
You have a ground position of a star. Yeah, so you understand that ground position of the star is 90 degrees, right?
Yes, that is the elevation angle of the star from the ground position will be 90 degrees because it'll be directly above you at the zenith. I don't know if you're talking, I'm not hearing anything.
Okay, sorry, buddy, just a little bit of technical issues there. You can hear me all right, yeah?
Yep.
Can't hear you at all. Just a mic check, please, mate.
Hello, can you hear me?
Yes, I hear you, buddy, I hear you. So, the ground position of a star directly underneath any star in the night sky, right, has a ground position directly vertically underneath it of 90 degrees to you with your angle measuring device.
It is
The sextant, yeah?
It is not 90 degrees to the observer. It is 90 degrees to if you were at the ground position, or elevation angle to that star would be 90 degrees. The horizontal at that ground position is not the same horizontal as your at your observation point.
Okay, so correct me if I'm wrong, and I know you will do, whilst doing celestial navigation. And what I'll do is I'll remove all of the dip correction and altitude corrections that we would have to do if we're on a surface. I'll put the sextant on the floor to make things easier for us, all right? So we don't have to do those dip corrections and other corrections. I can measure a angle up to a star. Let's call that angle 45 degrees, okay? And now vertically down from that star is a straight line, and it meets the surface of the Earth, and then a horizontal line to you. That angle between the vertical and the horizontal is 90 degrees, correct?
No, it is not. There is not a horizontal line between the ground position.
Can you provide me with a citation with that, please, then?
Absolutely.
Can you provide me with a citation for that, then, please? Awesome.
Sure.
Stuff, because see, this is where everything gets a bit confusing, because I can provide you with citation from many a celestial navigation book that talks about the ground position angle of a star at 90 degrees. So we're going to have a conflict of interest here, aren't we?
What they're saying is, at the ground position, yes, the star is at 90 degrees from that position, at the ground position. They are not saying that there's a 90 degree over to the observer. Now, you will find some simplified diagrams that look like they have a triangle, but that is not how it is actually done. And you can find numerous citations that show it with the actual curvature of the Earth the parallel light from the two different locations. And let me find you an example of one. I have one I use in the course I teach, but I suppose you will not take a diagram that I have created as authoritative. So let me find a different one that looks very similar that comes from some other source. So let me look. I have so many damn
Do you
folders
want to
here.
draw a picture over there? That might help him.
Gonna have to, I have to get the crayons out for him.
Let's see here.
Oh, look, I drew a horizontal line. Look, proof. Proof.
Okay, here's a good one right here. Let me. Should I cut and paste this into the live stream voice text? Do I have image privileges there, or how should I do this?
Yeah, should do, or you can post it to me if you don't, and I'll post it for you.
He can post links, but he can't. They won't embed, so he can only post the link.
Okay, well, I can
No, that's
I
fine.
could DM this to FE Jedi, unless someone wants to temporarily give me image privileges just to make everything go a little faster. I mean, I'm only going to be posting
We don't
nerdy cell nav stuff.
have a moderator in here with that ability
Okay.
at the moment.
Okay, well, let me go ahead and send something to one of you here. Hold on.
Somebody
Moderator.
do me a favour and ping a moderator.
Yeah, if there's a moderator listening, I'll also tag them.
Thank you, buddy.
Okay, I just sent an image to FE Jedi if he wants to copy that one. Let me see. Remember, do I have the actual source? That comes from a particular navigation book. Which one did I copy that one from? Let me look around a minute.
I just posted your image in the live stream for you.
Okay. This is an example of the kind of things you can find in a variety of navigation texts. And you'll find and like American Practical Navigator will have some various things that will show stuff like this. Another navigation book.
You literally, this is brilliant. Thank you for providing this, mate, because you're
Mhm.
literally showing the magic trick for us. This is going to be great.
Mm-hmm.
So what you're saying is you're actually measuring the angle from the central radial point of the Earth and the Earth's equatorial plane, yeah?
We're measuring the angle from the observation point. What we're saying is
Mhm.
that makes the same angle that you would get going from the center of the Earth through the zenith at the ground position and the zenith at your position. That is the same as the co-altitude from your observation point. You're obviously not tunneling
Awesome.
down into the center of the Earth, but the fact that you can
No, obviously not. No, obviously not.
The
Yeah.
fact that you can get that angle then allows you to then calculate that arc length on over the surface.
Awesome stuff. So this is where the magic trick takes place.
Okay.
So we see the horizontal line on the top of the curved surface, and that directly mirrors the one that is on the equatorial plane of the Earth outwards from the radial point horizontally across. Correct?
It's technically it's not the equatorial plane unless you were at the North Pole. You notice it's labeled as the celestial horizon on there. We're showing the orientation as regardless of where on the Earth you are, we're orienting the observer up above. But I mean, so that celestial horizon could be tilted relative to the equatorial plane. But otherwise, what you said, yes.
Yeah. So we noticed that there's at least two horizontal lines, one placed on the top of the ball like a seesaw, and the one that's cut straight through the middle of the Earth like a flat horizontal line. You notice that the two arcs marked as Z and H, where it pretty much look like a protractor, and you've got lots of straight lines. Measure an angle from that flat horizontal baseline to make your fucking triangle. You see that magic trick there?
Well, except for there's not really a triangle there. You just have angles that are forming arcs.
Yeah. But you do, don't you? You two have two straight lines from, let's say, your measurement point, just to keep everybody on track, is from the center of the Earth. Or we can use the one at the top of the ball. Doesn't really matter. You've got two horizontal flat lines to measure that elevation angle up to, haven't you? Right? You've got two horizontal lines, big man. You're not
No,
measuring a line off a
horizontal.
curve. So
Yeah.
yeah, horizontal line. So you're gonna admit that you do need a horizontal baseline to measure your elevation angle up to that star, right?
Absolutely. Horizontal, I think the part where we differ is that the horizontal line is not the
Admit it.
surface of the Earth in the globe model. So
No.
I want to try and keep this real friendly. I totally understand that we have differing views on this, and I'm actually not coming in here to try and like pick a real big fight. It's
Mate,
like
I've got a massive smile on my face.
I'm
Dude,
absolutely going to like
dude,
convince you
you're
guys or
fine.
something. I like to just
You're fine.
I just like to explore where it is we differ. And I've tried to do this before. I actually went on Oakley's show like a while back and was hoping, and it was silly because I didn't like know what his show was like that much back then. So I mean, let's have this discussion. Let's talk about where we differ on this. I'd love to hear the flat Earth view on how they see it working. And of course, they just piled on and just like made it into a dumpster fire. It would be wonderful
Yeah.
if we get to have a friendly conversation here instead. So
That'd be fine. I mean, you're literally just pointing out and have illustrated the magic trick for me, mate. So as far
Mhm,
as I'm concerned, you can talk all you want because you've already said horizontal line.
mhm.
Horizontal flat baseline for you to measure your elevation angle up to the star. We can use the one on the top of the ball, but that gets superimposed down to the central radial point for that horizontal line, the celestial equator, correct? So that horizontal line is where you're going to get your elevation angle up from. Because you can't get an angle from a curved surface now, can you? Unless you bastardize the idea, do some maths, and then give me this little drawing with two horizontal
Yeah,
lines on it.
and I mean,
It's,
if getting a tangent is bastardizing, yes, I will agree. We are bastardizing our way to a tangent in order to get this
well,
angle.
actually,
And I will
so
again say
hold
though,
on,
it's
two
not.
seconds, 2 seconds. Tangent line, that's fine. But
Hmm.
remember, I put the sextant on the floor, didn't I?
Hmm. Yeah, well, if
Just,
and
just to make things simple, because if we're at an elevation above that surface of the Earth, we're going to draw a tangent line from our observer point down to the horizon. Our next calculation is going to take us down to the surface of the Earth, which is why I made everything easier and put the sextant on the floor, so we don't
yeah,
have to draw tangent lines.
right. The well, you still have a tangent line. You now have a
To where?
tangent line that is the horizontal. The horizontal.
To where?
Uh,
To
just
where?
to the in there it's labeled geoidal horizon. Basically,
Oh,
what's happening. In fact,
oh,
I could give you guys a link to a really slick tool that shows you what's happening there. Where if you have an eye height
yeah.
that's above the ground, you have an angle that's going down to the curved surface. Your horizon is off in the distance. The point on the horizon off is in the distance. As your eye height becomes lower, that angle is starting to tip up, and the point to the horizon is getting closer and closer to you. As you get to the point where your eye height is basically right in the water, you've basically
Quick
now
question.
that sight line is tilted to where now it's horizontal. It is horizontal, and the horizon is at your eyeball. They are now the
What are
same
we?
place. So that
What
your
when?
On the
sight
flat
line and the
Earth.
horizon and the horizontal are the same thing. They are the same tangent line.
Yeah. So when we're making our reference to the horizon, it's not actually the horizon that we're interested in, is it? It's actually the ground position of a star that's a known distance at a certain time of year
It,
because,
it,
the stars come back this, that, and the other.
it
So
is
the
it
only
is it is
reason,
not. Yeah, it's not the ground position actually. No, it's not. We're
oh,
not
it's
actually
not.
aiming at the ground position. No, ground
No,
position comes completely from the nautical almanac. The only reason we're looking at the
um,
horizon is we want the zenith. We can
no.
measure directly from the zenith if we want, because we want the
How
coax.
far? How far away can the star be? As in
How
ground
far away can?
position along the ground position along the surface of the Earth, or geographical position, if you would prefer.
Well, I mean, you're limited by, um, eventually you can go like about a quarter of the way around. The star will be if the star is close to the horizon, you're going to get at your maximum distance to the circle of equal altitude, and then you can't see it anymore. So you're just not going to get that one, and that would be your maximum distance, which is about a quarter of the circumference.
We say what, about 3,000 miles?
Let me just do the math here. I think in nautical miles. So.
Yeah. So this is again maybe an area of contention that maybe you and I should discuss, because
Mhm.
that geographical position or ground position of that star is on the surface of the Earth, and we know the distance to it from me or you with the sextants, and we can
Right.
say that that star is 2,000 miles beyond the horizon, for example. Correct? Which is why we want to have a reference of the horizon, do our calculation, dip correction or altitude correction, which is why I put the sextant on the floor. and the geographical position is beyond the horizon at a distance of, say, 2,000 miles.
Yeah, I was going to say the maximum would be like close to 5,400 nautical miles, and you're right. The ground position is typically going to be much farther away than the distance to the horizon. The horizon may only be a few dozen nautical miles away, and your ground position is actually could be thousands of nautical miles away.
Yeah.
And your angle that you're
Exactly.
pointing your sextant is not pointing at the angle of where the ground position would be. It's actually would be much
No,
further
no.
than that.
Yeah. So we're getting a reference from the ground position of that star, we'll say, to keep the math simple, 2,000 miles away, straight horizontal baseline to me and you've just put the sextant on the floor, and that star in question is an angle above the horizon. Let's keep it 45 degrees to keep everything simple. We've just made a triangle. You understand that, right?
At the point you've put when you put your eye down exactly at the bottom, you have basically no line out to the horizon. The horizon is sloshing against your eyeball. So your dip correction has become zero only because you don't need to look down to see the horizon. The horizon is literally on your eyeball. And like, let me
What
find
stuff?
this. Yeah, let me get this link to show you what I mean on that.
Just quickly, and I know this might be a slight aside, the horizon's not physical, is it? It's not the geometric curve of the Earth. It's a horizon. It's an apparent location, right?
Well, I mean, what you see visibly with the horizon, the refraction is affecting that. So it is an apparent horizon in that it's not a geometric horizon, because the geometric horizon you'd have to look a slightly different location. But I mean, you're still looking at a physical thing in that there's water there. There's physical water.
Yeah.
But it's just that the position, the angle to it is slightly different than it would be if we had no atmosphere. That's all we really mean when we're saying we're looking at an apparent horizon rather than geometric. Geometric is what you'd see if we never had refraction, but we have atmosphere, so of course we have refraction. So
awesome. So we're just using the horizon as a reference point, right? To draw your tangent down to. Let's remove dip correction. Let's call it an altitude correction, because we can backwards that one as well. So an altitude correction, this is why I put the sextant on the floor, because that's what the math does. Is your correction will take your altitude down to zero. So we put the sextant on the floor.
The altitude correction, that's not actually what the altitude correction is doing. The dip correction, the altitude correction is dealing with the sight line to the celestial. So it's the upper line, not that lower one to the horizon. Your lower line is handled completely by the dip correction. That includes a component of refraction. There is refraction in that. The altitude correction is a refraction correction. The celestial, it is based on your sextant angle to the star. So depending on your altitude angle that you're reading, it changes based on how high that star is. Dropping to zero if the star is exactly at what's
horizontal, isn't it? Celestial.
No. The celestial body is going to be. I'm talking about the celestial body, the star.
I'm not talking about the celestial body. I'm talking about the celestial equator.
Okay, but you mentioned the altitude correction. The altitude correction is something very specific. The altitude correction, you are applying the angle that you have after applying the dip correction. So you've basically now changed your lower line of your angle being horizontal. So you've got that. So that lower line is adjusted. Now you still have to worry about the upper line that's going to the star. That is also affected by refraction, and the amount it is affected is based on how big that angle is. The closer it is to the horizon, the more it's affected. It gets less and less as it gets closer to the zenith. So when you're up to the zenith, you're basically, because you're cutting through the density gradient exactly perpendicular, there is no refraction. And therefore, the altitude correction is zero if you're looking straight up at the star. So that what we call the altitude correction, sometimes called the refraction correction, is only the upper line of the angle. The dip correction is the lower line of your angle. When you apply the two of them, you now have a elevation angle that has all the potential confounding things like refraction removed.
It's just making straight lines going.
Yeah, I mean, you got that. The area in contention, my friend, is, again, as I've pointed out, you've got two horizontal lines, one at the top of the ball and one going through the middle of the ball, and your correction calculations are going to take you down to a horizontal line for you to measure your angle off of. You're going to build a triangle between you, that star, and the ground position of that star back to you with your sextant that we put on the floor. The sextant is obviously just an angle measuring
Yeah.
device. That's
Okay. I agree.
Can I
That's
just
just an
point out
angle
too,
measurement.
what it
in
is.
can
It's
I
just
just
an
point
angle
out, Vic,
measuring device. It's glorified.
can I just quickly point out, sorry to interrupt, but in that diagram, I still don't see a 90 degree from the GP.
It actually is. If you look at where the GP is and where the line out to the light ray, how that's extending. If you were to like rotate that so the GP was up at the top, you could create a tangent line at the GP similar to that geodal horizon, and that would be 90 degrees. A tangent line at the point of the GP to that curved surface will be 90 degrees to the light ray. What they're saying, when they say that there's a 90 degree at the GP, they're not talking about it being 90 degrees to the observer. They're talking about your angle. If you were getting an elevation angle to the star from the position of the GP, it's directly overhead, therefore that elevation angle is 90. But I understand that from the flat Earth perspective, there's this belief that, well, of course, the surface is flat, therefore there must be a horizontal line running between the GP and the observer, and that would then form the base of a triangle, and that is helped
That's
along by
how
the
it's
fact that
described.
you do find some diagrams that look like that. I am here to tell you that those diagrams are very simplified things just to get the idea across of having an elevation angle. This diagram I'm showing you here is the way it's applied in the process. And I've actually demonstrated that by showing how that distance between the GP and the observer is an arc
We get a
length.
citation for that.
Like of my actual demonstration, yeah, I have a video. I don't know how many of you have
Can we
seen
get
the
a citation for that's how it's done in the process?
Well, this what I posted right here is an example of it. Actually, probably an even better example would be the guy who created the process, the guy who invented circles of equal altitude was Captain Sumner, like about 100 and some years ago. Let me see if I can find one of the pages from that book. Hold on a second. I'd been
Citation is, don't you?
I know I'm not going to go to all the doing it like I'm defending my thesis, but I can provide you a link or the what the actual the book is that you can get this information from, and I'll give you the page from the book that has the relevant section. So hold on a second. It's not the folder it's in. Appreciate you guys being patient. I think it's in this one. Oh, well, this is like a zoomed in screenshot from a video I made, but it is, I can tell you what page it is in the book. Uh, 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 oops, that's not what I want.
If I'm reading that picture correctly, by floating a rope in the water with a knot in it measures distances.
Well, you're talking about the original way that we measured speed on boats. Yeah, you trailed a rope behind, and how many knots would pass, along in the water as you would count, and then that would give you your speed. We have more accurate ways of doing it now. We have little devices you can trail in the water, and it'll measure the speed of the water much more accurately. But actually, I was using one when I was
So
sailing just a couple days ago.
yeah, so
Let's see.
any of that stuff requires flat Earth too.
Okay, so this is a section where the Captain Sumner, the guy who invented the kind of the circles of equal altitude method of navigating, is describing how you're getting the distance from the observer position to the uh, basically the edge of the circle of equal altitude. He's describing it an arc of a great circle passing through this pole which is equal to the complement of the sun's altitude. That's the co-altitude. So he is describing
Where are
it
you
as an
posting
arc.
it?
He's describing it as the. I gave it to FE Jedi again because I can't do images unless someone's gave me those privileges. So I can tell you exactly what page that is, and actually I can give you even a link to the book. Why don't I do that too? I can post that right in the chat. Let me find my actual. Find the.
Have a mod out there on YouTube listening in. Could we please give ProtoThad temporary image permissions?
I did post your last message in the live stream voice text as well.
Okay, I'm going to go ahead and send a link to this book. Google Books does these disgustingly long URLs. Post this in. Let me know if you guys can open that book. It's to a PDF of a copy of this book written by Captain Thomas Sumner, who's the one that kind of invented the concept of circles equal altitude. He does go in there and talk pretty extensively about how it's based on arcs over spheres, and all that sort of thing. I have a video I made specifically commenting to Brian's logic. Where I actually go through a bunch of these pages. This is in fact, this graphic I posted earlier, where I talk about where it has the highlighted part about the measured on the arc of a great circle is from that video, and there's some other pages I highlight in that where it's basically kind of him describing what's in that previous diagram that I posted of the way you're getting that distance from the observer to the GP is an arc of a great circle, going from that observation point. Actually from the GP. It's actually from the GP to your observation point because your observation point is on the circumference of the circle. And what I've done is I have another video. If I don't know if any of you ever seen my response to 10th Man video I did. It's the one that got me banned from the Fed server. that whole kerfuffle. If any of you were around for that, where I actually halfway into that video I walk through a position fix where rather than doing all the complicated spherical trigonometry of site reduction, I literally skip the math and just directly apply the co-altitude angle to get an arc length. And I use that and I measure that arc length on the surface of a globe. I draw the circles of equal altitude on a surface of a globe. And I show how they intersect at the latitude longitude coordinates. So it's taking the lines as they exist in the real world, that like we have circles we've created that are a specific distance from the ground position. I'm recreating those circles just shrunk down. And showing that on a globe, they will then intersect at the correct coordinates. I've done some other stuff where I've attempted to recreate that on a flat map, and it does not work on a flat map.
Flat map.
Yeah.
Flat map. Who provided you with this flat map? Which one out of the thousands of flat maps did you use?
This specific.
You understand? I said thousands.
Yeah, there's all sorts of different projections.
So without you, sorry, chatty. Sorry, you don't have to build a straw man because you've used a specific map and said, doesn't work on this map. Which map was it, just out of curiosity?
Okay, I've done it on two. I've done it on the azimuthal equidistance, so basically the Gleason, and I've done it on a Mercator. And it will not work on either of those.
You've done it on the Gold-Peterson? You've done it on the Gold-Peterson?
I don't think I have. I think maybe someone else has done that one.
Someone else.
Bacon might have done the Gall piece. I'd have to go look. He's done some other maps he's done it on. So But I mean,
So
that's,
you want
if you think about it, I
you
mean,
want
go ahead.
mate, you're very chatty. I thought this was going to be a conversation, not you just spouting your word salad for 10 minutes without anybody being able to interrupt you and call you to task on what you said. I'm just jumping over. I've done this on the flat map. I just don't want you to build a straw man and burn it down, mate. No one's provided you with a map. You've just picked one at random, haven't you?
Yeah, but if you want to provide me a map, I'll try it on any map you like.
Yeah. How did you get your latitude lines? When were they developed and how were they developed?
The latitude lines are derived from the motions of the celestial bodies. The fact that they travel in set.
Which one?
All of them. So
Which one?
what do you which
North
celestial
Star?
body?
Pole Star?
No. The I mean the North Star. I mean
No.
that's one that you can you can determine your latitude roughly. It's not exactly at the celestial pole. But what I'm saying
That have
is
been the original one was used?
it's the fact that when you
Would it
track
have been the
ground
original one that was used? Would it
which
have been the original one used?
which original one? What are you talking about?
North Star. Would it have been the original one used?
A long time ago, there was a different one, evidently. I mean, I'm not going to say that I'm an authority on was it really that way or whatever, but it's like supposedly, if you look at so much older text, you can see that it's shifted, and there was at some point a different one that was closer to being in the middle.
I'm not talking about whether there was a different one. I'm just talking about, was that the original one used to
Over
determine it?
250,000 years ago before the sextant was developed. Yeah, it's the same.
The point I was trying to make is that the fact that latitude lines track in the direction that they do is based on the fact that that is the direction that ground positions of stars move. That latitude lines are not arbitrary. We didn't pick the way they're laid out as some sort of arbitrary thing. They are meant to represent direction that ground positions move over time.
And you would have
And
needed
also
a reference point. Because they move, you couldn't use them to determine it.
I mean, well, we pick. Then you've got, of course, longitude is perpendicular to that, and we've picked sort of an arbitrary prime meridian. That we then use as an offset, and then the distance between longitudes is entirely based on how quickly does a celestial move at a particular latitude. So what we find is they move the fastest at the equator.
You would have needed a fixed reference point, right?
You pick a particular geographic location. You said, okay, this is where our prime meridian is. I have a particular star that comes directly overhead at at a particular time. But then over time, it's going to be moving a particular direction. It's rising in the east, moving west, and over a certain amount of time, someone directly west of me after a certain amount of time will see that same celestial directly overhead. How far away they are and how much time interval there is between those two times is dictating how fast that ground position is changing over a period of time. And that gives you how far apart longitude lines need to be at that latitude.
The ground position again.
So my point here is that latitude and longitude is not arbitrary. The prime meridian is arbitrary. You can decide to put a prime meridian wherever you want. We've all agreed on a particular one, but once
They're
you've picked
using
that prime
angles?
meridian, I mean we do use angles to track where the stars are, but you can do all this based on just looking for where these particular stars are when they're directly overhead, when they're at your zenith, and how they move is dictating how the layout of the latitude and longitude lines. They have to follow the motion of the ground positions, otherwise they would be useless for navigation. The latitude longitude lines have to match the direction of motion and the speed of the ground positions, otherwise they cannot be used for navigation.
Ground positions, so more than one
I'm sorry.
ground position.
I just
We're,
had a
we're now
question.
talking
Sorry to
about ground.
interject there, guys.
Okay.
Uh, uh, so
You're roboting, mate.
Yeah, someone's roboting.
flooding for me a bit. I'm not sure it's only me.
You're roboting pretty bad.
So I guess my question was about the thing Jedi asked about the North Star and the positioning. Like, how were you able to draw latitude lines if you didn't use a reference point like the North Star? So basically, you took the maps and then you took I guess the latitude and longitude points that they told you, and then you went to a different distance and then you use that as your next one and see if it looked accurate on the map. Like, how did you figure out those distances or the latitude and longitudes?
Well, I mean, my point I was making earlier was not so much about exactly how you were numbering specific which latitude you're at, but the fact that the latitudes are oriented the way they are. It's definitely you to decide where what latitude number you're at, what latitude you're at. You do want to use the north celestial pole, which yes, Polaris is very close to. It's actually not quite there. So when they were determining those, they weren't technically using Polaris. They maybe did in the very early days when things weren't as accurate. But when you want to get really accurate, you're actually determining that celestial pole point that's like a fraction of a degree off from where Polaris is. So that's that's how you're doing that.
So when I'm directly underneath, sorry guys. So when I'm directly underneath, for example, the pole star, it's 90 degrees. I move half the distance from the pole star to the equator. It's 45 degrees. And I'm at the equator at 0 degrees, correct?
Correct. I mean, it's pretty much.
Awesome. Sorry, you noticed I said angles there as well. So 45-degree angle up towards Polaris, 0 degrees up towards Polaris, and 90 degrees underneath Polaris, and every single increment in between 90 degrees and 0 degrees, right?
Right.
That's an angle we're talking about. So this is how
Yep.
your latitude
Absolutely.
lines were actually made. Yep. So again, angles.
Yep. I've never said it's not
45
angles.
degrees up.
Flat
Well,
baseline.
this is the thing. If you're going to be measuring angles off of a curve, you can't measure angles off a curved surface, now can you?
Absolutely, you certainly can. You can. Let me post you another picture.
Hold on. 2 seconds. We're going to have to ask you a very simple question. You know what a triangle is, right? 3 straight lines meeting at
Absolutely.
3 vertices where the interior
Absolutely.
angles can be measured and added together to reach 180 degrees.
Mhm.
If I curve one of those lines, 2 of those angles I can no longer read, correct?
You
And
don't
it is
need a
no longer a
triangle.
triangle, correct?
You don't need a triangle to get a single angle. From your vertex, which is your eye, you just need 2 points to aim at, and you can get an angle. And you will agree. Come on,
And those would be straight lines. And
you've used a sextant, right?
those
You,
would
you
be
used, right?
straight lines, wouldn't? Yes, those would be straight lines, correct?
Sorry, two points make a line. I don't know what the fuck he just said.
A vertex, and then 2 points that you're aiming at. I should say
Yeah,
two
and
So
right
you're
we put
going
the
to be
sight
section.
lines.
using.
Let's say 2 sight lines. A vertex and 2 sight lines can create an angle. You do not need that third line. You don't need that opposite side to your eyeball. You're just getting an angle. You don't need anything more than that. Because okay, so FEJ, you've used a sextant, right? You've measured angles with it. I think you might be dropping out.
I understand what you're saying about you only need 2 lines to measure an angle. Yeah, no, that's fine. I completely
Okay, so
agree. You
so
just need
so
2
so
lines. That's fine. But those lines
so,
would be.
so
Hold on. There's a question following, Chatty. Don't
okay.
make me lose my patience, mate. I'm being really cool with you. So those lines would be straight, correct? Sure. You
I
didn't
mean,
say that very
there's
loudly.
some
Say it with your chest.
we do have
Sure. Yes,
refraction
absolutely.
refraction
Yes.
adjustments, but we eventually end up with straight lines. Yeah.
Which refraction model are you talking about? And I don't want to then go off on another segue and start talking within the weeds, because we're going to be talking about celestial navigation from boats at sea from the mid 1700s using an angle measuring device.
Right.
Yeah, sure. Which is based on the premise of a triangle, a 90-degree triangle, right?
And that's
And
where we
I'll take
disagree.
you well back.
No.
Okay, so then you're going to have to provide citations for this.
I thought I
Celestial
just had.
navigation was developed. Celestial navigation was developed in the late 1700s, right?
And I gave you the book. I sent a link of the guy who did it. He goes in there in extensive. In fact, let me get another page out of that where he says it's based on spherical geometry.
Spherical geometry.
He's let me, and I'll read the passage out loud, but let me get the page where he specifically says that, the guy who invented this navigation process. Let's see, I'm on the wrong thing again. Okay, here it is. In the right folder, at least. Yep, this is the one. And open with.
You don't get to beg the question with tangents, so don't go there.
He doesn't use the word tangent, but this is back into. Okay, so do I have image privs now? Can I post this right in the text stream? I'll just try it. Up there. Don't think I do. I'll send it directly. And okay, this is a page from that. This is a page from that same book. And let me just go ahead and read it for the other people while you post it. Explanations of the principles upon which this method depends. To facilitate the understanding of the theory of this method, a reference to the following common definitions relative to spherical bodies may be necessary. And then it goes on to talk about if any plane or a flat surface pass through the sphere, the intersection of the surface of the sphere by the plane is the circumference of a circle. And he's laying the groundwork right there to talk about what we call the circle of equal altitude. Talks about great circles, small circles. Later on in the book, he talks about how that relates to parallels of latitude. But if this specific book, he goes in quite a bit of depth describing how the distances over the surface are arcs, and how this is happening on a spherical surface. And then I actually, in a video, I go through that section where I talk about the arc of the great circle passing through the pole in the complement of the sun's altitude. I actually step through and show how that looks like that previous diagram that I posted. And I have my own version of that I also provide. Let's see.
In practicality, you're cutting sections out of the earth, are you?
We're just
make horizontal planes?
No, we're taking arcs over the surface.
Assuming arcs over the surface. How you're doing it in practicality, right?
Okay. I mean, to do a particular method of navigation, you do have a presumption of what the Earth is like. Your validation of that presumption is, do you actually get to where you expect? Did you travel the distance that you expected? I have tested this by actually shrinking down the geometry described in the process and drawing it on the surface of a globe. There's a fellow who does a video. Oh, I'm trying to remember his name now. You guys may have seen it. It's the one where on the teaser for it has the Pink Panther holding a curved L, angle measure. But he goes through showing how if you draw circles on a Mercator map and project it back to a globe, they get distorted. Opposite is true. If you draw circles on the surface of a sphere, project them back to something flat, they will always be distorted. It is impossible to take circles you've drawn on a sphere, project them to any flat surface, and have them still look like circles. So the fact that I can make them intersect at correct latitude longitudes on a spherical surface, on a globe, means there is not any way to actually make them intersect on a flat map. Now, I've made that claim. I don't know that there's any way I can prove that to you unless we do it on every single map projection that's out there. I've tested it on a few. But if you accept the geographic reality of it is impossible to take a spherical globe surface, project it flat without distorting the distances, the fact that circles of equal altitude intersect correctly on a globe means they will not intersect correctly when drawn flat.
Should I go? Oh, he's back.
Okay, hey, FA Jedi, just see you posted a diagram there. It's interesting. That comes actually from a video by a guy called oh, I forget now the name of the YouTube channel, but I've been to it before. He does a variety of tutorials, and he actually in the description for that video talks about that it's not actually doesn't actually use triangles. It actually uses spherical geometry.
Just going to throw this out there just for shits and giggles. You understand that if the Earth was flat, which it is, but we'll say it is, you understand that that would be the flat horizontal baseline, and it would be really easy to make a triangle out of it, right?
I mean, if the world was flat, I would agree that you would use right triangles probably to do some sort of to find your distance to your ground positions to your navigation. I'm saying that you do not actually use a right triangle. You would agree that you never have the height to the star, right? I mean, this is an argument Globies and flat earthers go back and forth about. Globies saying, "Oh, if you have the triangle, you should be able to arrive to the height to the star." And then flat earthers say, "Well, celestial navigation, you don't have the height to the star." We actually agree on that. You don't have the height to the star, which, as far as I'm concerned, is an
Need
admission that
it.
you
You
don't
don't
have.
need it.
Okay, you don't need it.
Need it.
Okay, you don't need it. Can you get it? Can you get the height to the star?
Yes.
Okay, so you can use trigonometry if you have the angles of your triangle and you have one side. You can solve a triangle using trigonometry, right?
Yes.
Okay, so we should always be able to find the actual height of any star, because when we're getting the distance to the ground position, we know the angles. We know that there's a 90-degree over at the ground position. We know that there's an angle from our observation position. We can complete the final, if it is a right triangle, you can complete the angle up at where the star is. You've got all three angles. You've got one side, you've got the base because you know the distance. Therefore, you should be able to complete the other sides. You can use trig. You can get the height from the ground position to the star and the distance from your observation point to the star. You know exactly where that star is. It's your distance to it and its height over the Earth. The problem is when you try and do that math from different locations on the surface of the Earth, you end up simultaneously with different heights to the star for different observers at different places, because it doesn't obey the rules of trig. When you multiply that angle, the complement angle, by 60 nautical miles per degree, that is not a trig operation. That is not how you find the opposite side of an angle in trig. That is the arc length formula, exactly like that previous document showed. Just like that protractor picture you're showing. You can see that as you increase the angle, the distance along the curving part of that protractor increases by a steady amount with the angle. It increases by the same amount as the angle, essentially, at the same rate. Because multiplying a constant distance by an angle is giving you a curving arc length. If you want to get a flat distance, you have to use a trig identity, sine, cosine, or tangent. And then as the angle increases, each subsequent degree is increasing by a larger amount, which is not what we see when we do celestial navigation. That's how we know we're getting an arc length, not a flat base of a triangle. Some flat Earth sextant enthusiasts I've talked to, their change to their description that I've heard recently is like, well, we are getting an arc. We're getting an arc in the sky, and then that somehow transforms into a flat distance on the ground. They never really explain how that transformation happens, but that's what they're saying. But in the process, we say that we're just directly getting that multiplying 60 nautical miles per degree by that co-altitude angle. That's just giving us the distance on the ground. We never talk about that being some magical distance in the sky. And that diagram that shows the angle from the center of the Earth is showing why we're getting the distance on the surface. Now, I get that we disagree on that. What I'm saying is I've done a practical implementation of that model by taking a protractor, measuring an arc length on a globe, matching the co-altitude angle, physically drawing the circles on the surface of the globe for each of the stars that I have a co-altitude angle for. And they actually intersect at the correct latitude longitude coordinates. Implementing that geometry as described in the text physically on a globe, and it renders the correct result. If the Earth is flat, there should be a way of doing something like that flat and getting the latitude longitude coordinates. I have been asking for over a year. When?
You said you cut a section out of Earth. You admitted that that's your concession, that you can't use a curved surface to obtain your angles.
I don't use a flat plane when I'm getting that distance. I'm using an arc over the curving surface.
How are you cutting a section out of Earth then?
I mean, that's just saying the geometric concept of you can have the circumference of a circle be on the surface of a sphere.
Just use the curved surface. Then just use the curved surface.
I just use the curved surface. I don't use the plane.
No, you can't use a curved surface to obtain elevation angles.
Absolutely. Let me post you another picture. I mean, we already agreed.
Absolutely. You said absolutely, like you can do that. Angles require straight lines, not curved surfaces.
Right. But the surface, we don't use the surface of the Earth as a line in the angle. And therefore, it doesn't matter that the surface of the Earth is curved because the angle we're getting is not using the surface of the Earth.
Because you can't use a curved surface to obtain the angle.
That is the fundamental. I understand this is the fundamental disagreement that we have. From the globe perspective, and this is what plenty of the documents describe, angle that we're getting, not on the surface. The line for that angle is not on the surface. Meets the surface only at a point. And it's getting us...
begging the question? I said no tangents. I said no tangents. You would be begging the question, sir.
I'm just describing the way we're doing the process. We can validate this by doing the process. I did
use colorful words and try to mix it all up. You're still using a tangent, and he said no, you're not using it.
Well, then you're not going to do celestial navigation. So it's like, I guess I'm telling you how I do it. Now I posted something like before I left the coffee house earlier today, where there was some actual sextant angles. In case supposedly a couple of you guys have actually done this stuff. I wanted to see, if you wanted to work through those sextant angles and show how you use a right triangle to do it. I would love to see that. The process as I do it, I don't use a right triangle. I'm using
when you use the sextant, when you use the sextant and you're establishing a horizontal baseline, a use of the horizon to get your elevation angle, is it a tangent?
Is it a tangent? Yeah. When I'm aiming at a point on the horizon, my eye is above
that.
I mean, you can look at the diagrams that show how dip correction is done. I mean, technically, you do have a little bit of refraction. So there's a part of your initial sight line is slightly curved. When you correct out the refraction, you have a line that is a straight line that, and then to that, then you you adjust
What
for
would
the
that
geometry to
that
go to that
refraction be
horizontal.
based upon? What would that refraction be based upon?
It's empirically derived from the fact that we've been studying this stuff for centuries. You I think, made a good suggestion earlier of like, let's not
Would
get
it be
hung up on
based
the refraction because
upon?
it's a relatively small. You're talking about arc minutes, and you could ignore it completely if you want to use a bubble sextant and just measure from horizontal directly. In which case, you're not aiming at the horizon anymore. You're aiming at a point above the horizon. If you have a bubble sextant, it's leveled to a point that is above the horizon. It's definitely not at the surface of the Earth because the horizon dips below horizontal. We know that because we have to apply the dip correction. The bubble sextant, we don't apply it. That horizontal line is at some distance, some angular distance above horizon. So we can, if we can use a bubble sextant, we can just not even worry about the horizon. Don't worry about dip correction. We're almost getting the elevation angle directly. We still have to deal with refraction adjustment, the altitude correction for the line up to the celestial body, but we can apply that, and now we have a elevation angle, a classic elevation angle. It's horizontal at one point. It's got an angle up to a celestial body. But at no point is that the surface of the Earth, because that horizontal, we know it's not pointing at the Earth, because we know that the horizon dips below horizontal. Otherwise, we wouldn't have a dip correction.
That's a funny word, dip correction. Dip correction. What's the dip?
The dip is the fact that the angle from your eye to the horizon is pointing slightly downward. It's not pointing forward. It dips
So
from
you
horizontal.
know what the horizon is, right? It's where the sky meets the ground.
Right. Yes.
So
Yeah.
your feet are touching the ground. So it's actually the distance between your eyes and your feet. There's no dip correction. It's just so you can put yourself at the ground in a straight line. No
Yeah,
curves.
I've heard flat earthers describe it that way. And I will agree that as you get lower and lower, the dip correction gets less until if your eye was in the water, it would become zero because the horizon is now against your eyeball. The horizon is actually at your eyeball. There's no need to look down because the horizon is right there where you're at. That does not mean that the surface continues horizontally. If you look at the diagrams in celestial navigation manuals, it shows it curving. I can show you one from Harold Jacobi from like 100 and some years ago. They depict the curve of the Earth, horizontal, dip correction, the dip angle, and it shows that the dip is going down to a curved surface and the horizontal is above the surface. This is the way the mariners were
Is
saying it
is
was done 140 years ago.
is the definition of elevation angle that I just posted in the live stream voice text, is that correct?
Okay, let me scroll down. Uh, elevation angle is angle between the horizontal plane and the line of sight. Yes, but do you believe that the horizontal plane has to be the surface? Is that the surface of the Earth?
What you would be
So you said
establishing with the sextant, right?
yeah, he agreed that the horizon is where the sky meets the ground. Now, ask that question again.
Do you believe the horizontal plane is the surface of the Earth? If I'm standing up at the top of a building and I'm getting an elevation angle with a horizontal plane that's with my eye, is that horizontal plane the surface of the Earth? And remember, there's a dip correction, so the horizon is always going to be pointing lower than horizontal.
Did I or someone else can you take this?
I mean, let me post another image, like an actual definition of
Horizon isn't physical.
Sorry, can you repeat that,
And
Jedi? Your robot.
obviously,
Okay, I'm posting another one to FE Jedi. One of the when you do if you do a Google search on elevation angle or angle of elevation in Google, this is one of the probably off right off the first page. I added the red text that says, "Note: the Earth's surface is not aligned in this angle," because you have the angle of elevation is above horizontal, and below it you have the angle of depression. And the horizontal is at your eye level. So from my standpoint, when I am applying dip correction, I am not thinking of it as lowering myself to the surface. I don't get down in the water and use my sextant with swim fins. I am raising the lower part of that angle up to my horizontal. And you can find references that talk about it that way, in fact, depict it that way. You find a few that talk about that the tables are written as if you are down at the surface so that the dip correction is 0. Because you still need to apply you don't know what your dip correction is until you actually apply it by plugging your height of eye into the dip correction formula. And therefore, you want to start with the tables being 0 so you can apply that correction. That doesn't mean you ever actually are at that 0. It doesn't mean that we're actually using the surface. We're never actually using the surface as our horizontal. Our horizontal is just horizontal. It's going to be looking straight ahead.
Is the horizon where the sky meets the ground surface
Yes,
of the
absolutely.
Earth?
I agree to that. And that point is below
Okay, so
horizontal.
your feet are standing on the ground when you do that. So your dip correction is the eye height to the ground. That's it. That's all it is.
The dip correction is not your eye height. Those are two different. The dip correction, the eye height is what you plug into the dip correction formula. The dip correction is what comes out of that correction formula. You've got what the input to the formula and the output. Height of eye is the input.
Dig a hole in the ground and make yourself even at the beach at sea level and do it that way. Then you don't have to do any numbers, do you?
Yeah, but then your horizon is right at your eye, and that's why you don't have to look down. It's also a real poor way to do it because refraction gets worse at the surface. That's where you have your biggest temperature changes, so you're really better off being higher. Something I was going to post before we kind of went off on a little bit of a tangent. Let me see if I can find it. I mean, but we at least agree that the sextant doesn't need any kind of physical surface to get an angle. We're just arguing about
it needs a horizon, right?
I'm saying to get any angle. You could measure the angle between two different lighthouses. You could tip it sideways. You're doing landmark-based navigation, and you just want to know the angle between two lighthouses because you're going to navigate that way. You don't need any surfaces to do that. A sextant is completely capable of getting
unless
an
you
angle
use the horizon, it's pointless then using it for celestial navigation, right?
For celestial navigation, you absolutely, if it's a mariner sextant and not a bubble sextant, you absolutely are going to use the horizon.
What's the difference?
You're going to do your corrections. Okay, so there is technically in just getting the angle, there is no difference. You're just aiming at a point.
Exactly.
There's no need for a surface.
I have to step away. I'm still listening. That's why I can't stay engaged.
Okay. I would say that our disagreement is simply on the definition of an elevation angle. And I think this is a very important point. This is something I'm kind of glad we got to this point because I feel like this is the thing where we always get mired down in these discussions is we fundamentally disagree on what an elevation angle is. Whether or not you need the surface in order to get an elevation angle. You can use the surface to get an elevation angle with a mariner sextant. It's a convenient thing because you're on a rocking boat. A bubble sextant doesn't work that great. You can't use a theodolite, that sort of thing. And so you're using this stable reference point, which is the horizon, and you're using some math to adjust for things like the dip and refraction and stuff like that to actually get the zenith. You don't actually care about the elevation angle. The elevation angle is just an indirect way of getting the co-altitude angle. And there are actually ways of doing celestial navigation in which you measure directly from the zenith. I've worked on digital systems that do that. for the military. I can't go into a huge amount of detail, but you can go online, you can actually Google these things, and you can find out about how these systems generally work. Where you've got sky-facing cameras, motion stabilized sky-facing cameras that are measuring how far the celestial body declines away from zenith rather than how far up it is from the horizontal. And then you can skip that whole subtract from 90 and all that kind of stuff and just jump right to the part where you're multiplying by 60 nautical miles per degree and you're doing all the rest of the celestial navigation exactly the same. You can do the same thing with a theodolite, by the way. So you don't need some fancy military equipment to do this. You could theodolites, you can't really use on a boat, but you could go out on land somewhere. You could set up. You can really, and theodolites are great because they're very, very accurate. They get down to like arc seconds rather than fractions of an arc minute. You can pin down your GPS or your lat long very precisely, and particularly if you're picking stars that are fairly close to the zenith, because of course refraction is less as you get close to that. You can actually do some very accurate celestial navigation, which is what was done when we did all of our initial land surveys. Is theodolites are literally, they were doing celestial navigation to pin down lat long coordinates using theodolites, and it's essentially the same process as we do on a boat. We just get the co-altitude angle differently.
I take a poll of the
Ruhif, is that you? It sounds like you.
Yeah, but my audio.
Yeah, you're a little bit quiet. I posted like about an hour or so before I got jumped on. I posted them some sextant angles in case someone wanted to do a position fix, and we could talk about our results and how we got them. I don't think anyone did.
You guys, is that better?
Yeah, I can hear you better.
Okay, cool. Yeah, sorry, there are a lot of peanuts in the chat with a lot of opinions.
Yeah, and you're not going to run the show either. So how are we going to do this today?
Just asking a question. Is there any flat earther here who can demonstrate that they can do celestial navigation? That's my only question. That's it.
Celestial navigation or done a position fix. I did ask the same thing earlier, and I don't know that I've gotten a definitive answer. People were saying earlier that there are people who have done.
Are you asking if people have used sextants in here?
Just whether you can demonstrate getting a position fix. It don't have to be a sextant.
I mean, you can get the angles from whatever device you want to use to measure the angles. You can get them from someone else who's actually used the sextant to get the angles. The question is, can you take the sextant angles, the elevation angles, and turn them into latitude, longitude coordinates? There's numerous challenges that have been put out there. I posted one to the Heliocultist channel earlier with a set of 3 sextant readings that if anyone wants to show that they can do it, I've got in I've got a really good set that I did just here off the coast on the coast of Lake Michigan that I do in my video, my response to 10th man video that I did last Christmas. Anyone wants to hop on and do those? I give the answer in the video, so you can check your work.
The question is, can you use a nautical sextant without the use of a horizontal plane?
Yes. I mean, you're not actually directly using a horizontal plane when you're getting that angle reading because your sight line is not. You are mathematically establishing a horizontal plane.
You just literally just said you don't need a horizontal plane to obtain an elevation angle. That's what
you said. Use a sextant. You said use a sextant. You didn't say get an elevation.
And what is the sextant used for? What is the sextant used for? Is it
to
gain elevation? Elevation angles. Thank you.
That is one use. I'm sorry if we kind of got it, cross points there.
That's what it's used for. Just let it be.
Okay. But I'm saying that we disagree on what that elevation angle is. That horizontal for the elevation angle is not the surface of the Earth. And I can give you survey text that cite sources that say that horizontal is not
You
the surface
saying
of
you
the Earth.
don't need the surface of the Earth to navigate the surface of the Earth?
That you don't need the surface of the Earth to get an elevation angle.
So
That
then,
is
what do you
not
get
a
an
requirement.
elevation angle from?
You can get it from horizontal. If you're talking about with a marine
Horizontal
section,
of what?
okay, let me make sure I'm a little more clear here. The surface of the Earth is not a line in that elevation angle.
What is the line?
The line is just horizontal, which is not the
Of
surface.
what?
The angle, the elevation angle. We have a
Angle
horizontal
from what?
from the observer's eye
The observer standing on.
on the deck of the boat.
And where's the boat?
The boat is in the water.
And where's the water?
The water is all around you.
Uh-huh. Contained in the earth.
Yeah. But
Right. So the observer getting the elevation angle is getting the elevation angle up from the earth.
they're getting an elevation angle from their eye. I know that the flat Earth interpretation of that is wanted to say that you're bringing your eye right down to the water level, and then somehow that magically means that the horizontal at that point must mean that the surface now is flat.
Because the horizontalness is of the earth.
And that's not what
particularly the water.
That's not what the sources say. I gave
They're
you a
wrong.
reference.
They can't defend that.
You're saying the celestial navigation sources describe horizontal as being tangent. Sorry, I said the dirty word. As being a line that only touches the surface of the Earth at one point. Those sources are wrong.
A line that touches the surface of the earth.
Correct. That's
so an abstract entity is touching the earth.
I mean, yeah, you were. That's what you were.
Yes, it is.
You were the one who was getting very adamant about the fact that our boat is in the water. That point where we're making contact with the surface.
You're the one citing sources about celestial navigation. I didn't cite a source. You seem more enthusiastic than me. So
yes,
there is no sense in saying that the horizontal line is the water, the earth. Right? There's no sense in saying that. That's unintelligible.
I guess I'm not quite 100% sure what your point is, but
it necessarily means that the horizontal line is the water, the earth.
No, I disagree with that.
So if it's not the earth, then what is it?
It's a point that's just extending straight forward.
It's a point. A point is a geometric concept, which is abstract, correct?
It's a sight line, if you want to call it that. A sight line that's going from whatever point you're starting at, which is typically your eye, straight forward, horizontal,
perpendicular to down.
An elevation angle from what? Up from what to what?
From my eye. You want to say that it's
from your eye?
The surface. You want to say it's from the surface. I disagree on that. We fundamentally disagree on that point.
What sense does this make? You have to avoid the obvious conclusion. You know full and well the pattern of reasoning that the flat earther is arguing for is clear and not obscure and sequitur. You have to obscure what the horizontal line is at the bottom of the triangle, and then even have to deny that there is a triangle in principle involved.
There isn't a triangle. I've never seen any flat earther demonstrate how they use that triangle.
So the celestial object, number one, the observer, number two, the tangent point underneath the celestial object, point number three. Those 3 points with 3 lines between them connecting them. That's a triangle.
The line, your sight line to the celestial, and the zenith line from the ground position up to the star are parallel to each other. That is fundamental.
Say it again. What'd you say?
Parallel.
What did you say?
They do not converge together.
Say what you said again.
Your sight line from your observation point to the celestial body, the zenith from the ground position of that celestial body, are parallel lines. They do not
They're
converge
not.
at the point of a triangle. You
I'll
see
post it
They're
in the
diagrams.
not parallel.
Then how can a bubble sextant read the same elevation angle at different eye heights?
There is no sense in what you're saying. The line stretching from the ground point up to the celestial object is vertical. The line stretching from your eyes to the celestial object is diagonal. They're not
And they're
parallel.
only
They
they're only
converge at the celestial object.
Can you see the diagram in the chat, Gregory?
I'm not talking to you right now.
Can you see the diagram in the chat?
I'm not talking to you right now.
All right, fuck you too.
Okay, I will talk. You are presupposing that line between the observer and the ground position is a straight line. I'm saying it's not. It's a curved line. The reason those angles diverge at those two locations is because your orientation to the celestial body is different at those two locations.
Back up and turn off the religious apologetics for this ridiculous cosmic doctrine. The line stretching from the GP up to the celestial object is vertical. Up to the celestial object. The line stretching from your eyes to the celestial object is diagonal. They are not parallel. They converge at the celestial object. Do you understand that so far?
They are parallel, and let's talk about bubble sextants for a second. If I use a sextant at close to sea level,
this is patently ridiculous.
And you have someone 40,000 feet directly above me also using a bubble sextant, will they read the exact same elevation angle, or do I need to
ridiculous and being ridiculous?
Do I need to apply some kind of correction? You answer that question. Do I read the exact same elevation?
Stop talking. Being ridiculous.
Yeah,
deceiving people.
This is an important question. This answers your question if they're parallel or not. Because if they're the same elevation angle, they must be parallel.
You just whistled past what I just said.
Your premise is faulty.
I'm answering what you said.
Your premise is faulty. Sir, your premise is faulty. You can't go off to another point when your premise is eroded. You can't do that. Gregory's pointing out that your premise is faulty, and you want to skip that part and go to another point.
Your premise is based on the idea that the distance between the observer and the ground position must be flat. You're unwilling to entertain the idea.
No, what I just said to you, not what you insist that I said to you, what I did actually say to you. Do you understand the line stretching up from the GP to the celestial object is vertical, yes or no?
It is vertical.
Do you agree that the line stretching from the observer to the celestial object is diagonal, yes or no?
Yes, it is.
Do you agree that I just said two sentences in which two lines are going to a single point, the celestial object? Yes or no?
They are not. They are going to something with no parallax. Therefore,
Christ alive! Wow.
Not converging.
Not what I said to you. Right. Some other thing I didn't say to you.
That was a mental contortion that you just done when you should have just agreed with him. That mental contortion that you just interjected with, you didn't allow for the logical consistency of the point to unfold. Why did you do that? I want to know why you did that.
Because you were trying to jump to a conclusion about the celestial object.
Jump to a conclusion.
He's leading you. He's directly leading you from point to point on the conversation. I mean, everybody can hear this except for you. You're trying to divine his thoughts. You just stop doing that. Just go along with what he's saying. Either agree or disagree, and then if you disagree, then you better back it up with why you disagree.
Okay.
So he's basically either agree with what he's saying or but we don't hear that. You just jump to your point and you forget to say why I disagree with that based on whatever logic. You don't have anything. So either agree or disagree with him based on the logic that he's presenting.
So resuming at the last question I said to you, do you agree I previously said two sentences which are talking about two lines converging at a single point, the celestial object, yes or no?
No, they do not converge.
So I didn't just say that?
I'm saying you may have said that. I don't agree that they converge at that point.
Why?
Because the star is massive. Therefore, given the distance of the Earth, your sight lines can go to that star without converging. The star is
such an asinine non sequitur pattern of premises.
But let's say we can disagree. You can say that we don't have any proof of that. You don't believe whatever. But you have to agree that if that was the case, it would allow for parallel light waves.
No, even your appeal to parallax is ridiculous. It's an asinine non sequitur line of premises.
We can prove it. We can prove it.
The
We have
in
measurements to prove it.
principle doing the math. No, you cannot prove it.
Yes, it is.
You need
This
logic
is
in
why
order
I
to
took
do
it.
math. Do you understand that? Do you
Let's
understand
go
that?
back to what I said. Yes, I
No,
understand
no.
it. And
Do
I
you
can prove it.
understand
I can
that?
prove it.
If we
Yes.
can't agree
Yes,
that
let's
we
go.
need logic to do math, there's no point in this.
Okay.
Do you need logic to do math?
Absolutely. Let's do some math.
Okay.
Would you let me go
With the
through a scenario with
logic,
you?
right? So with the logic, right? Not insist on what you're trying to say, on your asinine non sequitur pattern of premises. It's very simple. There's a line number 1 stretching from the GP to the celestial object. There's line number 2 stretching from the observer's perspective to the celestial object. That's 2 lines, 1 line, 2 lines from 2 points, the GP and the observer's position, to the celestial object, point number 3. There's 2 lines converging at 1 point in principle and practice. Do you agree?
Nope.
Why?
Because we measure that they are parallel. We measure that they do not converge. And I was trying to explain that point to you, and I can still
How did
explain
you
it.
measure that?
With bubble sextants. You get exactly the same
What?
elevation angle at the surface as 40,000 feet in the air.
That's
If
horse
they converged, they
shit.
would be different angles.
That's
They would be
horseshit.
different angles.
That's horse
That is
shit.
absolutely true. It
You
is 100%
know that.
true.
I don't know why are you saying that? That's horseshit. How are you going from the GP to where the observer is and saying they're parallel? That's utter horseshit. If you're passing that off as logic, then whoever's listening to it and following the same line of whatever cockamamie idea that you have is probably as confused as you are. Like, I don't know who sold you this lie and you hook, line, and sinker bought it. Like, you're what are you trying to talk about? Because it doesn't make any sense. Logically, it doesn't make any sense. I'm listening to you.
The light is okay. If the light is not parallel, if it's diverging between the observer's position and the ground position, then it would also have to be diverging when you're 40,000 feet up above. It couldn't be parallel to those 2 points while being diverging at some other point on the surface, could it? I mean, it's all light from the same source, right? It's diverging
Fucking
in
retarded.
every direction.
An elevation angle of the celestial object, right? But the angle that is your line of sight isn't even pointing at the celestial object, which you're trying to measure the elevation angle of. But somehow you successfully got the elevation angle of that object, but you're not looking at, because that makes sense.
A protractor.
You're looking at it in both cases.
Listen, dude, a protractor can debunk your horse shit right now. A simple protractor can debunk your horse shit, which is like, I don't know why you would. If somebody can use that simple tool, then they can just easily debunk you right now with what you're saying.
You should be able to take elevation angles from sextant angles. I provided some earlier today, and show this process on a flat surface, and show how that results in latitude longitude coordinates. You should be able to show.
I'll do it with that one.
Flat.
What tool did you use? Did you call it a bubble sextant?
Bubble sextant. A bubble
What is this guy? Who is this, Greg? Who is this guy? Where do you
I
come
don't
from?
know.
Like,
Pray for him.
I mean, okay, my name is ProtoThad. I'm a guy who's been sailing and doing celestial navigation for 35 years.
Oh my God, you're that guy.
I am ProtoThad. I'm that guy. So if you want to see an example of this stuff as a worked solution, you can watch that video, my response to 10th man video. I walk through the geometry of it there and show how the geometry on the curving surface of a globe, directly applied with no fancy math, directly applying the co-altitude angle as a curving arc length, yields the latitude longitude coordinates.
You're talking about celestial navigation that sailors do, correct?
Yes.
Okay, what you're saying though is you're presupposing the Earth being a globe, right? Isn't that what you're saying? Because there's no way that you can tell by doing this that the Earth is a globe. I want your confession on this right now.
I am saying that is the only geometry that yields correct latitude
No,
longitude.
No. That's not what I'm asking though. Is it evidence that the Earth is a globe? I need your confession in this chat right now.
Yes.
Okay.
Yes.
Okay. So you're telling me with using this, we know that the Earth is a globe.
Yes. Doing celestial navigation.
You're presenting this information, and it is like a just so case, right? It's got to be right. because there's no other solution. It can only be this. It can only be a globe.
I
mean,
would love,
according to you.
yes. Well, okay. There's one kind of crazy thing. If you want to imagine, there's some sort of really wild reverse refraction where we're actually on the inside of a sphere, and everything's being refracted and bent such a way that it only appears like it's not all bunched up in the center. The math, the curving math of doing the actual circles of equal altitude work on the inside surface of a sphere the same as they do on the outside. So if you want to become a concave earther and say, oh, look, site reduction and celestial navigation, the surface plotting that we do, the actual navigation, the distances all match up on the inside of a sphere.
Okay, enough.
On the outside.
Enough. Look at what I tagged you in the live stream voice text.
They do not work flat. They absolutely do not.
Look at what I tagged you in the live stream voice text.
Okay, let me go.
On Wikipedia, as it simply says right here in the screenshot, ships had long used sextants for navigation, but sextants had problems in aircraft navigation. A ship at sea is on a relatively flat surface and can use the horizon, which is horizontal, flat, to measure the altitude of celestial objects.
Okay, let's just scroll down. Let's go past where.
Okay.
Yeah, there it is. I found it. Yeah.
So sailors are on a flat surface doing celestial.
So if you're going to, if you want to grab that and say that proves that Wikipedia proves that the Earth must be flat, then that means
attack the source. Why is the source not okay?
Except no, I'm fine with Wikipedia because Wikipedia has countless.
Okay, so the source is fine. So I proved my point.
So countless other articles that says the Earth is a globe. So if you're saying this one says that the Earth is flat, then you must say that the other ones that say the Earth is a globe. Well, why not accept those? So now
because it's incoherent. It's logically incoherent.
You're playing a game of confirmation bias. This is just confirmation bias.
In principle, whether they do, I doubt that they really do. But in principle, if they do, I reject them because they're incoherent, untenable.
So that confirmation bias. You're rejecting the ones that.
So not confirmation bias. It's a specific objective premise that says it is logically inconsistent, implying absurdities.
But I am saying that I have gone out and done the worked solutions that show that the geometry is spherical. That's
you've done what?
The actual worked solutions, the actual getting latitude longitude coordinates on the surface, navigating distances between the position fixes over the surface, getting those distances.
So you worked it out. You worked it out, ProtoThad. You worked it out mathematically, and therefore it's a globe, right? Because you worked it out mathematically, correct? Isn't this what you're saying?
I'm saying that I measured distances, actual distances on the surface.
No, you worked it out.
Cannot
you
work
worked
on
it
a
out
flat surface.
You worked it out mathematically, though, right? You didn't apply this directly to the Earth.
If you get on in your car and you drive
I feel like
some
you're
physical
avoiding my
distance,
question.
have you measured that distance?
You've avoided my question. That's the second time you've avoided my question. You're using mathematical concepts, and you're not directly measuring the curvature of the Earth. So either
I disagree. And I say I'm actually.
You're directly measuring the curvature of the Earth.
I'm measuring an arc length. The process that I'm using is I'm applying an arc length. It's rendering the correct answer, which means it must actually be an arc length. Otherwise, it wouldn't be.
You're doing math. You're not directly measuring the actual Earth itself. You're doing math.
You never use math when doing a measurement.
What I'm telling you is that you're taking math to be reality, and it's not. It's a language that interprets something that you're actually using it for. It's a tool, sir.
I'm applying the measurements I get with a sextant directly without applying math. I'm taking the co-altitude angle and applying
utilizing
it
the Earth.
You're not
directly utilizing the Earth as a flat plane.
Not as a flat plane, as a curving one, because I do it on a globe.
No, you didn't do it on a globe.
I did it on a globe. I did it on a globe.
No, you didn't do it on a globe.
Have you watched the video?
You don't exist on a globe.
And why does it work on a globe?
It doesn't work on a globe.
I have a video that shows it does.
No, you don't.
Can you
didn't do celestial navigation. right? The
But why does
diagonal
it,
line from
why
your
does it,
perspective is not pointing to the celestial object. If you're not looking at the celestial object, the thing which you're supposed to be measuring the elevation angle of relative to the surface of the earth, which is flat horizontal, then you do the task.
I'm hearing a lot of presupposition in all that.
No, it's not a presupposition.
It sounds
Not a
like
single presupposition what I just
you're
said.
starting with the belief that it must be flat, and therefore
No,
throwing out
no, no, no,
any
no, no.
applying it to a different
All right,
model and
you want to hear
staking
about
it.
belief?
No, I'm not just presuming it's flat. We only see a flat surface.
ProtoThad,
It
you want to
looks
That's
hear
what
about
we
belief?
only
it comes down
experience.
to I look
ProtoThad,
at
hang
it and
on,
it
hang
looks
on,
kind
hang
of
on, hang
flat to
on.
me.
ProtoThad, 1 second. You want to hear about a belief? You want to hear about a belief? What were mariners using before the idea that the Earth was a globe? What were they using to travel the oceans of the world? What were they using to travel the
Dead
oceans of
reckoning.
the world?
They were using dead reckoning, which is not
Were they
celestial.
using what you're using? Were they using what you're using right now to presuppose that the Earth is a globe as a belief, sir?
No, but the fact that
All
the
right,
process I have works.
then, no. So what I'm getting to right now is the belief is actually yours, not ours. It is yours, not ours. Do you understand that?
Okay, yeah.
So
I've
the
actually
belief,
tested my belief. I've actually
it doesn't.
tested my belief.
No, you did not test your belief. You worked it
Then
out on a piece of paper or on a
no,
calculator.
I got on
Or
a sailboat and I
no,
sailed from San Francisco
I don't
You won't
care.
down the
even
coast
test
I
the
of
don't
logical
care.
Maine. I
coherency
just
and
sailed.
consistency of your doctrine.
You're
You
doing
haven't
the same
tested
thing.
anything.
You're doing the same thing that the mariners of old have done. They've traveled the waters of the world doing the
No,
same thing. But you're just
I,
now
I
saying that
applied I
math,
applied a different process, and
yeah,
that
and then
process
you come
yields
up,
information that gives
it
you
doesn't matter
yeah.
because they were
No,
still
it doesn't.
traveling. They were still traveling in the same direction, going to the same places that they were actually traveling in without presupposing that the earth is a globe and still arriving in their destination. They were still doing that in the days of old. So you're telling me that just because you're working it out that it works on a globe in your idea is that it's now a globe. No, you're wrong. You're the one hung up on a belief. The idea that the earth was not traveled on the waters of the world weren't traveled as what you're, I guess, 30 years traveling the waters of the world. But people long ago, thousands of years ago, were traveling the waters without thinking that the earth was a ball. So they were still arriving from their point of origin to their destination without having this presupposed silly notion that they live on a ball. And now you are saying that because you have this idea that you live on a ball, then you've just solidified your belief as its true knowledge, where you're incorrect. Because if that was the case, then they couldn't arrive to the place that they took off of, from the place they wanted to be at, if that was the case, because they would be all going in the wrong direction because the Earth is
And they
actually a
often did.
globe, not a
And
flat
they often
plane.
did. Do you know the history of the British naval disaster of the Scilly Isles? You ever heard of that? That was
Okay, so
before we used the
where is
current
that?
kind of special navigation. Thousands
Where
of sailors died
Where-
because they weren't where they
Okay,
thought
so
they were.
you're using a very hyperextended event just so that you can make a point, but you're
But
not looking at the overall
that was
understanding. You're not
that was
looking at the overall understanding here, ProtoThad. You're overlooking thousands of years of travel over the oceans to your 30 years of thinking that
absolutely
the
not.
Earth is a globe. Yes, you
I'm
are. That's what
absolutely
you're
not
doing.
overlooking
So
it. In my
you're
class
the
that
one.
I
You're the
teach about
one.
how the Polynesians were
I'm
way
sorry,
ahead of their time.
but you're
The
the one.
Polynesians were
You're the
way
one.
ahead of their time with celestial
Listen,
navigation,
you're
but
the
they had
one
a
who
different
thinks you live on
system
a
that didn't
globe.
do position fixes.
You're the one who thinks that you live on a globe,
Yeah.
and the globe is actually the new kid on the block because a lot of people didn't know that there was thought of that the Earth was a globe until like almost recent times, and you know
Yeah.
this. You know this. So people
Can I
weren't
talk?
bamboozled by this information. I'm just
Can I?
making. I'm drawing light to the fact that you're actually making light of that. You have this understanding that the Earth is a globe, but
I
you
have.
failed. You failed to mention that before the times where you're talking about, thousands of years ago, people were traveling the waters of the world as a flat and stationary plane. And
Mhm.
you keep negating that by talking
Absolutely
and
don't. Can I
opening up
talk?
your incoherent pie hole to say that you're traveling over a globe. You don't.
Can I say
You need
something?
to mention that,
Wilmer,
ProtoThad.
can I say something? I absolutely do not negate that because in the celestial navigation class that I teach, I start with talking about the Polynesians and the type of celestial navigation they did before we could do precise position fixes. before we could actually like determine longitude and those sort of things. And I give mad props to the Polynesians. They sailed thousands of miles, and they did it with some very innovative techniques of watching the seabirds, of looking at the ocean currents and understanding how the surface of the water looked different on the down current side of islands. They had lots of really great things they could do. But they also still were not able to get it as precise. More of them were lost at sea.
They did it successfully anyway by your own premises.
They could,
regardless of how precise or imprecise you arbitrarily want to make it.
But I think the fact that you're saying that I totally discount that and that's really unfair. No, I actually, the people who
I didn't hear it.
Before we could do, I didn't say that in this thing, but I want to.
On your opening statement, when you were talking, you did not even have a mention of this, and I was only hearing that you were saying, "Well, you guys have the belief that the Earth is flat," and you didn't mention, "Hey, guess what, guys? Before even the Earth was thought of as a globe, people were traveling on the Earth as a flat stationary plane."
Yeah, flat earthers successfully did celestial navigation in their sailing endeavors.
So what we have here is somebody muddying the waters or poisoning the well, as it were, with your idea that you think that you're going to trump this room by saying that, oh, we got it right now. But what were they doing before? You didn't mention that. Where did we start with?
And then has the nerve to fix his mouth to derogate me as having a confirmation bias.
Okay, can I talk now?
I just want to see this globe. I just want to see this globe that celestial navigation is working on. Can we just get to that?
I mean, do you want to see the video where I actually walk through?
No.
How
no,
we
I want to.
do these circles of equilibrium?
No.
I mean, I would like to talk a bit about about the people who navigated before.
I want to see the globe it works on. The globe it's working on. I want to see that.
Like just an image of the globe that I've personally used to do it.
No, the globe, the one outside that's supposedly being navigated on.
The image of the globe you personally used, so a toy, a fabricated toy.
But the arrangement
you said
of the latitude
there's
and longitude lines.
There's horizon dip, right? Because the surface is curved, right?
The audacity of these globe believers, man, I cannot stand it. How they want to. I just can't stand it. It's the audacity for you to come in here in a room full of people who understand history, and for you to say that, well, we know that you guys have a belief because the Earth is a globe, as a matter of fact, and it's your belief that the Earth is flat when you don't even go through history. Well, you should, right? At least.
Can I talk a bit about history? Because, hey, mad props to the people who managed to get from place to place without being lost at sea, without being able to get a precise position fix. The fact that we can now get a precise position fix.
But you didn't mention, what was the method? ProtoThad, you can't skip. Listen, if you're giving mad props to these guys, then tell us the method by which they use to navigate the waters of the world. If you know it, and if you don't know it, listen, if you don't know it, don't miss. ProtoThad, if you don't know it, don't misrepresent them. No, you're talking about you're talking about a culture. You're talking about the Polynesians. You're talking about only one specific culture, where you're negating the fact that many other cultures have traveled the waters of the world.
I could talk about the Vikings and their use of a sun compass. They basically were hitting on the idea of latitude.
Okay, you realize you're shooting yourself in the foot. This is where we get annoyed with people the likes of you.
Exactly.
Like you're literally conceding that there are flat earthers who successfully did celestial navigation, navigating the waters of the world. That's a refutation to you.
No, it's not. Because if you
how is it not?
How the celestial navigation system works and the information it yields evidence of a globe.
No, it doesn't yield evidence of a globe.
Have you ever done it? Have you ever done a position fix?
No, I've never done celestial navigation. I'll be the first one to admit this. And still, with what I do know already, I can clearly conceive of the logical sequitur premises that you have 3 points all intersecting one another, and you have a horizontal line like I just read at the bottom of that triangle like I just read on the Wikipedia article.
If that worked the way you said, then bubble sextants would not work the way we see them.
No, the bubble sextants are working. And
if they're working,
there's the horizontal line, which is the flat surface of the Earth, and especially the surface of the waters. You just refuse to come to that conclusion.
Well, about that flat surface of the Earth, ProtoThad, I remember you saying that the surface must be curved because there's a dip angle to the horizon. Is that true?
I will say that That is what the formula we apply. We're applying it in part because of curvature. And I've actually graphed the formula, and it shows that it creates tangents to a curving surface. If you wanted
Okay.
to believe that actually it's yielding those results because there's some sort of funky refraction that's
Got a
actually bending
question.
the light in some way, you could make that argument, but that doesn't negate the fact that the measurements of the surface that we do yield curvature. And that's
You're
where my
saying that
argument comes down
there's
to.
a dip. Look, you're saying there's a dip angle because the surface is curving, right?
That is a large part of it. Refraction plays
Okay.
a role as well, but majority of it is based on the curvature.
Okay, you're already trying to get your excuse in there. So the horizon must be geometric then, right?
We do not see a geometric horizon.
Oh.
The horizon we see is a result of both geometry and visual effects like refraction.
No, you can't have it both ways. That's horseshit. You can't have it both ways. ProtoThad, stop being disingenuous, bro. You cannot say it's geometric and optical. You cannot do that. Don't do that in the chat. You're gonna have to choose one or the other because
But that sentence is vague on its face anyway.
you can't do that.
That's ridiculous. You're saying
ridiculous.
No,
sir, it's ridiculous what you're saying. You want us to believe a human being is telling us that something can be static and fluid at the same time.
No, I'm saying that you're seeing a physical thing that is slightly shifted by an optical effect. Just like you see through your glasses.
Shifted. You're seeing a physical thing that's slightly shifted. Oh, so then how
the visual appearance of it is slightly, but it's still there's still a physical location where that
Let's see it. Let's see it. Let's see it. Let's see it.
That isn't even the definition in your paradigm. That isn't even the definition.
When you put your glasses on and it changes things optically, does the thing you look at cease to be a physical geometric thing?
What are you talking about?
We need to pause and pay attention to his words. Yes, we live on a concrete real object, that's the Earth. And the concretely real object that is the Earth, the surface thereof, the general topographic geometric surface of the Earth is flat, level, a plane, not curving, concave or convexly. We know this because we don't empirically detect in the first instance any curvature to then measure it.
I understand that you feel it looks flat.
So that's not a feeling. It's not a feeling. It's visually detecting.
ProtoThad thinks that too, because that's what he's telling us when he invokes refraction. He's saying, well, yeah, no, it is a geometric tangent point, one that we don't see. And then he goes to refraction. So he's actually telling you that it looks flat too.
The refraction.
Well, then how would you draw a tangent to it?
The refraction actually plays a very minimal role.
No.
It's the fact that the Earth is very large is the reason.
No. Stop. You're invoking too many variables. By the way, you just blasted your foot. You didn't even shoot your foot. You cut yourself off at the knees. Like you're really hindering any thought process for you to you're projecting this idea that we can't know anything anymore. Because how are you going to tell? If what you're saying is true, how is anybody going to know anything? How are you going to measure to this distance? If it's something that looks like it's maybe there, maybe not, you don't really know.
Well,
how are measurements going to be done on this supposed globe?
He says that he did it. He says he did it with a horizon dip angle, a dip angle to a geometric horizon that he also said he doesn't see. How's that work?
Yeah, one that's moving around because it's moving around.
The dip correction includes a refraction adjustment.
It's a geometric tangent point. That's why there's a dip angle, but it's a geometric tangent point that you do not see. Therefore, there's a dip angle. Come on, man.
No. It's the correction that we do when we do the dip correction. It includes a component that is because of the geometry and a component that's refraction.
That would be circular reasoning.
It definitely is circular reasoning.
I'm just telling you what the source.
We know that there's a refracted horizon because there's a geometric one that we don't see. We know that there's a geometric horizon that we don't see because we see a refracted one.
But there's a dip angle because of the geometric one, not the refracted one that we actually see. Get the dip angle from what?
You contradicted yourself, ProtoThad. Congratulations.
If you guys want to doubt, what you're seeing out there off on the horizon or whatever, that's fine.
Stop projecting your error onto us.
Yeah, that's what you're doing.
proof,
That's exactly what
of
you
the
told us.
globe
You're the
is
one.
not
You're the one
based on
saying that.
those angles. The
ProtoThad, you
proof of
just
the
finished
globe
telling
is
us.
the lat long
You just
coordinates in
finished
the atmosphere.
saying that it's geometric and it's also optical at the same time. You're the one doubting what you're seeing, not us. We know the thing that we see in the distance is there. You, however, are saying it may be or
I
may
think it's
not
there
be.
too. I think it's there. I think we're
Huh?
having a breakdown in language. I mean, let's lower the heat a bit here, guys. I mean, it's
No,
like I think
you're not going to make your position true by repeating yourself ad infinitum. Stop trying to be a witch.
We all heard what you said. That's why we're telling you that it doesn't make any sense and that you're projecting onto us your thoughts of it not being real. Because we're telling you.
okay,
So you're saying
we both agree the ocean is a physical thing. That when you're looking out at the distant horizon, that there's
So you're going to try to
water
repeat
up
it
below
again.
that.
Because
Agree it's a physical thing.
repeating what we just refuted is going to make it true, right?
I just want to make sure if we can get on a common point of agreement here.
Okay,
We both
say
agree
your
the world is a
argument.
physical place. And do we agree that refraction exists, or do we doubt that there is refraction?
Did we ever
How
even
do
give
we
you the
feel about that?
impression that we doubt that refraction exists? Why is
Okay,
that a question?
So we both agree that the world is a physical place, but the refraction affects how we see it. I
Uh-huh.
don't see where we disagree. I don't see where we disagree.
Light behaves according to the medium that it's emitting in.
So what are you saying? And if you know how refraction works, then tell us. Because if you think that you know what's going on in the distance with refraction, and that refraction plays a role as to how you see something in the far distance, then you're gonna have to explain what refraction is. And I need you to cite that shit. Put it in.
Like the light will bend toward the denser medium. So when we have a density gradient in the atmosphere, it bends down. When we have
density gradient. What the fuck are you talking about?
I won't argue that with you. If you guys want to believe that that refraction is working differently.
Stop talking about your projection shit. Listen, you're talking about a less dense medium, greater dense medium. You're not talking about what it actually is. It's Snell's law. Did you know that? Go read the definition of Snell's law.
Yes, I know about
read the
Snell's law.
definition. Okay, then read the definition of Snell's law to everybody, so we can all hear you say the words of what it actually is, instead of the horse shit that you're telling us right now.
Let me say this very clearly. Let me say this very clearly, since he is trying to appeal to the density gradient. The gradient is vertical. Okay, the gradient is vertical. It gets less dense the higher you go.
Mm-hmm.
So when we're looking horizontally, the gradient is not decreasing as we go away from us horizontally. So your appeal to a density gradient is insufficient.
And that's not even refraction anyway. So go ahead and read Snell's law for us. And can somebody post it, please, in the live stream voice text? So in case he misrepresents it, we'd be able to correct him on it. I want you to read it. Read it to the whole class, if you don't mind, because you're incorrect, and you're going to find out here in just a moment.
Okay, so I assume you're going to find something where you're going to interpret as they have to be different mediums, like different.
Oh, so you know. Density. So so you know.
You think that air of different density doesn't qualify as
no. You already know. So you listen, ProtoThad. It seems like you already had this in the hopper. You already know where we're going with this.
I've heard other people make the same argument. Yes, I've heard other, but you can see proof that that's not the case. You can see demonstrations of refraction in the same medium with just a density gradient and see that the light reflects.
That's horseshit. That is utter horseshit.
There are videos of it online of lasers being bent through a density gradient in a medium of one fluid. So you know that it doesn't require, say, like two completely different types of medium.
You're a fucking liar right now. That's what you are. You're lying right now because you can go find the evidence of it yourself. That is not refraction, by the way. And in whatever, and in whatever scenario that was being used, it's probably a hyper case. A hyper case, which means that it was a condition that was not a normal one that we would normally be out in. It could be due to like heavy smoke or fire or some shit, and where you're seeing like the light beam doing something else. That's not the conditions like going out to the beach someday. That's not it. So when you're actually talking about refraction, it's Snell's law. You need two fucking medias. You do. That's just what you need for refraction to occur.
We're gonna have to disagree on that point.
Well, no, it's not about a fucking disagreement. This is just a right or wrong thing here. You're just wrong, and we are right because this is how it actually operates. It operates this way.
I have applied it in my job, and a density gradient in the atmosphere, absolutely Snell's law applies to that. I
Yeah.
know you're not going to believe me, but I guess we're just going to have to move on that point.
Okay, ProtoThad, no, listen, just listen, just listen. Snell's law is a formula used to describe the relationship between the angles of incidence and refraction when referring to light or other waves passing through a boundary between two different isotropic media.
You're fucked. You're fucked, dude, and you know it. He read you that's the fucking definition. You're fucked. You can't get out of this. There's no way out. You're done. You're fucking toast, bro. You're okay,
so
nothing.
you believe refraction
You're
doesn't
fucking
happen in the
toast.
atmosphere? So you think
No,
refraction
you're
doesn't happen?
denying. No, fuck. I don't want to talk about that. I want to talk about how you're just wrong about what it is. Because he read you the fucking definition and you're not agreeing with it. You need to agree with it. And if you disagree with it, then tell us how you disagree with it.
Because same materials of different density qualify as mediums of a different density.
Then fucking rewrite it then. Go back into all of history and academia and rewrite that shit. Why hasn't that been rewrote? Because that's not the fucking definition for refraction. Snell's law is that he read it to you right now. So you're fucking toast. You're done. So your horse shit is not going to pass in this server as gospel truth, as you like to say it is. Because you want this fantasy global fictional narrative to exist.
I'm sending you a link from uci.edu that talks about how Snell's law applies to the atmosphere.
Some other fucking zealots. So you're gonna refer to some other zealots, such as yourself. Some other zealots, such as yourself, speaking out of context. I don't want that. I want somebody to disprove.
The context is atmospheric refraction and how Snell's law applies to it.
You're not getting away from this. You're not getting away from this. You're gonna. This is the hill that you die on right here. This is the fucking hill you die on right here. So you need to tell us how Snell's law is incorrect. Tell us how Snell's law is incorrect.
I'm giving you the link to it right now. So let's see. Am I in the live stream voice chat? Yes, I am. Okay.
This is worthy of also being mentioned. We already know why you're going to argue in defense of this doctrine the way you are with the devotion that you do, because you are stuck in the sunken cost fallacy. You and your 33 plus year career, you and all your teaching, this is an essential aspect of your worldview in your daily life. So of course you're not going to give this up, because you have to concede to a lot of unpleasant truths if our position successfully refutes yours.
Except for you guys have never applied this stuff. That's the
problem. Not whistle past the point. Not whistle past my point. Not whistle past my point. No, not whistle past my point, right? No, not that. We know why. It is not because you are just this emotional robot that makes no value judgments whatsoever, and you just only care about truth. Everyone wants to think that about themselves. That is not human nature. It is simply dishonest. We know why. So what do we expect?
What I'm getting from all this though is you guys are arguing definitions and never actually testing your claims in the real world.
What you're talking about is not refraction.
I just sent you a citation refraction with other ones.
He just read you the definition of what refraction actually is versus your horse shit that you want to spout off as what it is.
Your confirmation bias means you will not look at any of the other citations that tell you that you're wrong. Because I just gave you one, the very first hit that I found on Google.
A fucking weasel, dude.
That immediately said that you're wrong. That Snell's law applies to a gradient in the atmosphere.
Because you're a fucking
weasel. What is this? Right, hang on. What is this? What is this link? Who is this from? What is this? These websites that just have black text on a white background.
Some other fucking. It's probably, Greg, I'm telling you, it's probably some other internet bobblehead like a McToon or some shit. Well, like this ProtoThad character who waxes himself intelligent, is a fucking pseudo-intellect, who thinks they know what they're talking about and spouting off utter horse shit just to make a narrative sound plausible. And like right now, he can't refute Snell's law. He's like, oh, I know what you guys are going to talk about. You need two media. Yeah, he knew exactly where we're fucking going. So he wants to negate that by giving us some other fucking wizard out there who said some other shit that doesn't have any coherency to reality. Now he's stuck. He's stuck. And he's not going to be rescued out of the hand of truth. He's not.
Yeah, Gregory. So what you have here is C. McLinden, a student at wherever.edu. He drew this up on his little spot on a website, and that's all.
Thank you, Redwin.
And you have the nerve to repudiate us for appealing to these concepts, but you just did the same thing.
I mean, you threw out your definition source. I'm throwing. We can find plenty of them. I can find plenty of them that tell you that Snell's law
doesn't have any coherency to. It doesn't have any coherency to reality.
But
Snell's
this is what
law
I was
actually.
Your side argues from definitions. I went out and applied this in the real world and showed how the geometry.
No, you did not. No, you did not apply to real world.
This
is where you're
Snell's law that he's applying. Snell's law that he's applying, and it's not a predictive model. It's added in after the observation to match expectations, and it's based on a presupposed radius of the Earth.
And when you go out and do the act in the world, it's one medium, the air.
That's it.
It's air with differing densities.
No.
And the differing densities is vertical, not horizontal.
Right, which is why it refracts downward.
No,
that's not why.
Keep saying the same thing. You're not.
That is absolutely what the sources on this tell you. If you do,
you
didn't just stop at that one definition that you felt confirmed your bias.
If you would just stop at that one definition that confirmed your bias.
You would find the explanations that go into
You would find the explanations if you would stopping at the definition that confirmed your bias.
He's mad because he knows he's wrong and he doesn't know how to spin it. You don't know how to spin it to rescue. You're not going to rescue yourself from this. This is the hill that you fucking die on right here. Because you can't rescue yourself from here. You need two fucking media. And as Gregory pointed out, you only have air.
You're saying there's no atmospheric refraction. Are you just saying there is atmospheric refraction?
No, we said what we said. There's the air, and the density gradient is vertical.
Okay, so it's vertical, and what's the significance of that to you?
Right, and so the refraction which you see, right, the distortion of the light that you see is not because there's Earth curve. And it's not because there's two media there.
We're seeing refraction for some other reason than there being a density gradient. Is that what you're arguing?
For some other reason, there's not two media there, and the density gradient is vertical.
Answer this question. Is there two media when you're looking off into the distance? Yes or no? Is there two media? Yes or no?
There's more than two, as far as I'm concerned, because the density keeps changing.
What the fuck?
So there's a bunch of non-air media in the air?
There is media of different. There's media of more than one density.
No. You're dead here.
Two different media, not density of one media.
Yeah, that's your applying your confirmation.
No, your
reading of that definition.
Wow, that spell doesn't work, pal.
Bro, he read you the fucking definition. What the fuck are you talking about? Why do you keep projecting that it's our definition? Did we make up Snell's law? Did we? Answer the question. Did we make up Snell's law?
Didn't make up Snell's
law. You laugh because you know.
You're interpreting that text incorrectly. That's what I'm saying.
What's the error? What's the error?
The error is believing that the mediums of different densities need to be different types of material.
Well, let's read it again. Hang on. Let's just read it again, because perhaps we did misinterpret. Let's see. Let's just read it again. Let's see here. Let me read the one that Heretic posted. Let me read this one, and then I'll read the previous one that I read before this. Snell's law in optics. Wait, what the hell?
Sorry, it wasn't meant to be a response, so I reposted. Go ahead.
Snell's law in optics, a relationship between the path taken by a ray of light and crossing the boundary or surface of separation between two contacting substances and the refractive index of each. Right? You have the air and you have non-air, supposedly from you. But we only have air. one substance, one medium.
You're fucking toast, bro. You know it.
Okay.
You fucking weasel, dude. You know you're toast.
Or how about this one from Physical Classroom, again posted by Heretic? It reads, quote, refraction is the bending of the light path, the path of a light wave as it passes from one material to another material.
Okay.
You're done. Okay, what? You're done. You're fucking toast.
And lastly, before you talk, but hang on, hold on to your butts. Last one, the one that I read in the first place, that Radwin posted. Snell's law is a formula used to describe the relationship between the angles of incidence and refraction when referring to light or waves or other waves passing through a boundary between two different isotropic media, such as water, glass, or air.
How did he interpret that differently? How are we misinterpreting that? He's reading it verbatim to your dumbass, and you're rejecting it. Are you still rejecting it?
Yes, I'm rejecting that your use of
no, you're
Snell's law
nothing. I'm talking about the fucking definition. How are you rejecting that? Not what.
What is our error in the interpretation of the passages I just read? What is the error?
My use of Snell's law in actual engineering, optical engineering, you can have the same material, different densities, and it's still applies.
Stop. No, I don't care about your horse shit. Refute what we just said. What Gregory just read to you. Refute that shit.
What is the error in our interpretation of the passages we read?
That the different mediums have to be different actual materials and not just different densities.
Okay, that's not an different density. The density is a property of a particular single given substance. That's why it's called density. It's a property of a particular substance.
Okay, so when the air is at a different density,
so that's not an instance of two different substances.
Yep, that's it. You're toast. You're fucking toast, you weasel.
If you have air of different densities, then you're saying that
no. You can't keep repeating.
That's one substance, not two
or
more.
Are you saying there's no refraction?
No, I said what I said.
Refraction is not due to Snell's law. Snell's law plays no role in refraction.
No. You're adding that horse shit.
It's antithetical to what I just read to you.
You're adding that horse shit right now, and he didn't say that. You're adding that horse shit.
You're saying ProtoThad.
You're the one denying that two or more media is required for Snell's law to be manifest. That's you, not me, you. Again, not me, you.
I am saying that the two different mediums just need to be different densities.
And then you're wrong.
That is
of the definition.
That is equivocation at its finest. That is utter equivocation. A density gradient is not an instance of two different substances, but you have the nerve to tell me and us that you did this career with all this knowledge for 30 plus years and you teach it to other folks.
And it's called the ProtoThad law, I believe now, because that's all you can have, just made up shit, dude.
I'll say it again. A density gradient is not an instance of two different substances. Density in the nature of the case metaphysically, because when you do physics, you necessarily must have math and ontology.
Yeah. So why
what you're saying is ontologically inconsistent and absurd. An instance of density is a property of one substance. There's a density gradient in the air, not the air and the non-air.
Can I get a word in here?
You're not getting a word in there. No, you're gonna be. This is the hill that you're not gonna reach. You're gonna die on this hill, man. Everybody's gonna know it, ProtoThad. You are gonna either be outed as a fucking weasel, or you're gonna die on this hill where you're gonna try to make your excuses up.
Why is it when we compute the attenuation of radio waves in an atmosphere, essentially the refraction of them, that we apply Snell's law? Why are we using Snell's law?
Why do you apply something that is not appropriately applicable because you made an error according to your fallibility and depravity of man? How about that for an answer?
I like it.
Give us a citation. Give us a citation for that as well.
Okay, let me do a little bit of Google searching here.
You don't have it, you fucking weasel. You just
Keep it
made
right
shit
at
up.
my
No.
fingertips here.
You just
He
made
says
something up on the spot.
uses
Now, fuck you. You just
they
made that shit up on the spot. You just
he
made
says
that
he
shit up on the
uses it.
spot.
I'm
Yeah,
telling
he
you what I'm
uses it
doing my
every day
job.
for the last 30 years, but he doesn't know where to find it.
Exactly. He just made that shit up, dude. You're a fucking weasel right now. Let me look it up. What about the 30 plus years you fucking navigated the oceans, you dumbass?
I mean, we're getting pretty far off track from celestial navigation on
Fuck
arguing
you.
this because
We're getting off track from celestial navigation, even though there's air everywhere, including on the water and the air.
I mean, this applies in the dip correction. Once you get that angle, how you compute your latitude longitude coordinates on the surface is spherical geometry that cannot work on a flat surface. And if you walk through the process,
What do
you
you
can prove
do?
that.
No shit.
ProtoThad.
No shit. When you try
ProtoThad.
to do calculations according to a fantasy that is antithetical to reality, yeah, it doesn't work with reality. So what?
It's not
Right. What do
calculation.
you
It's
do? What
applying
do
the
you do?
geometry
What do
correctly.
you do?
Applying it correctly.
ProtoThad. What do you do when your standard refraction doesn't account for the observation?
When the standard one doesn't. I mean, if you have the
What
actual, like say the current temperature and barometric pressure, you can apply corrections that will give you a different index of refraction that will get you a more accurate result. Sometimes you just have to accept that you're getting a little higher level of error because you don't know what the exact weather conditions are. That's the danger of using a mariner's
you
sextant
do?
looking at the horizon where there's higher levels of refraction.
So
What do
there's a
you do?
possibility
What do
you
you do
could be
in that instant?
unsuccessful in your attempt to do the calculation. So what?
And you'll get some level of error. It's a relatively small. You're
What
usually
do you
talking about
do? What
what
do
it
you
means
then do when standard refraction does not account for the observation? What do you then do?
when it does not account for the. You're saying like you see something like a black swan or something. What you're saying?
The observation you're making, and you're using standard refraction, and it doesn't account for the observation because it's not matching your expectation. What do you then do?
I mean, if I'm doing celestial navigation, I'm just making my observations and doing the best fix I can, and I may get a higher level error if there was more refraction than I thought. I guess I don't get what you're asking.
You people just cannot say the words "I don't know," because that's obviously what you're indicating to us.
I mean,
You just
if
won't
you
allow
want,
yourself to say that.
if you want to argue that what we see at the horizon can be very variable because weather conditions cause optical effects, refraction, I agree with that. I have always said that. That's why something like the black swan is a crap argument for flat Earth because we have refraction, we have very variable effects, we have optical things that happen.
Say the logic sequence. Say the logic sequence. Boom, boom,
Observing
boom,
the
boom, boom.
globe
Premise to premise to concluding premise.
is not based on what we see at the horizon. It's based at how we navigate the surface.
It still doesn't make any sense. I want to hear the logic sequence.
What logic sequence are you looking for now?
You're sitting here trying to refute the black swan, the appeal to the black swan. What is the logic sequence?
Okay, the logic sequence is when you argue the black swan, you start out with a straw man. You say that the distance to the horizon can be no more than some distance. That is not the globe model.
In the math,
why is that incorrect?
That is not that is not a straw man. It is in the globe math.
It is not.
I want to hear. I want to hear. Why is it incorrect?
It is incorrect because that formula that you're using, that 1.22 times the square root whatever, that is assuming no refraction. You apply a refraction correction, you actually get a slightly
So
different.
then your paradigm, your formula is wrong.
But that is not the formula that we use. That is a formula. That is
What do you use?
We use standard refraction, which is a different constant. I don't have it right at my fingertips, but I could find it for you.
Find it. We're not going to move anywhere until you find it.
We also apply
7/6R.
Yeah, we also apply a correction when we know different weather conditions. So that number, that distance to the horizon, can shift quite a bit if there's a large amount of refraction. And so that
the distance to what?
Horizon, the distance to the horizon. That's what we're talking about when we talk about.
So the Earth is changing size all the time?
Of course not.
So then the horizon is not moving.
The horizon moves because refraction changes.
But the Earth doesn't move. You just told me.
We're not saying the Earth moves. We're saying that the path of light is being refracted.
What is the horizon?
Horizon is that point where
the edge of the sphere, yes? So the horizon is the edge of the sphere. The horizon can only change if the sphere changes, correct?
Nope. Because refraction bends the path of light. Horizon bends the path of
ground, ProtoThad.
The refraction bends the path of light. You bend the path of light.
The path of light to what?
To that point.
What are we seeing? Horizon. The horizon is the edge of the Earth, right? So we're looking at the Earth. The Earth didn't move. The light is not being distorted that much that the Earth is increasing in size, my guy.
The Earth is not moving. How do you not get this? The Earth is not
moving. We get it. You don't realize you just won't allow yourself to see that I'm reducing your premises to absurdity. The horizon in your paradigm is the Earth, the edge of the Earth.
Right.
The horizon can only move if the Earth moves. But the Earth isn't moving, so the horizon isn't moving.
You're seeing a different point on the surface because the light is being bent, and therefore where that sight line.
It's complete idiocy.
You
don't increase the size of. You don't have this refraction you're talking about through the air itself. No, you do not.
So you're
the air is not a silly mirror in a fun house.
Okay, so this is where we're to. We're saying refraction in the atmosphere doesn't happen. Okay.
No, it doesn't happen what you're saying.
Okay.
Okay? Yes, there's distortions in the appearance of the object. It is not increasing size, right? It is not increasing size by several miles. The air is not a silly mirror in a funhouse. The air cannot get that thick unless by a miracle of the God himself.
Okay. I mean, I understand that you seem to have very strong beliefs about that. Okay.
Okay, so acknowledging that I believe what I say, there's no refutation to it, so the refutation stands. By your own premises, you don't see what you saw, what you suppose you saw.
You wanted a link about radio attenuation. I'm going to post something there since we got a little far off track, but I will come back to this. Hold on one second. I just don't want to say that. I don't want you to think I completely forgot that we were talking about that. Oh, where is the?
We were discussing your supposed refutation of the Black Swan, and we just got to the point that you think that we're using a straw man against your paradigm. Then we established what your paradigm truly is, supposedly, and then by that paradigm that you said that you suppose, you still don't see what you suppose you see.
Okay, so the Earth is a particular size. It does not change size. If there was no refraction, you could see the horizon as a straight line to a particular point on that curving surface.
What the hell are you talking about? I thought the horizon is the edge of the ball.
He needs to define refraction.
Okay, let's and I'm getting to that. Let's go through it, walk through this a bit. We have a sphere of a particular size, an unchanging size. Fraction is 0. I have a sight line, a straight line to that edge, which is the horizon. Now
you don't.
We apply.
No, you don't.
This is a hypothetical. I want you to understand why refraction changes the distance to the horizon. Okay, so we have
not using straight lines. You won't. Not using straight lines. You will not.
Let me refraction.
Let him finish.
Let me walk through the hypothetical here. We have a straight line, no refraction. This is a hypothetical. It gets to a particular point on the sphere. Now, let's apply something that causes that straight line to bend downward. We are no longer looking at this point. If we don't change
the straight line is your line of sight, correct?
Just a minute. So if we don't change the direction our eye is looking, and we've bent that light ray downward, we're no longer.
Hang on. Just I want him to finish this because I can address this. Please go ahead.
So our eye is looking in that same direction. What we were looking at was the edge of the sphere. We have this effect of refraction. It's bending it downward. So now suddenly what we're seeing is not that edge, but something lower. That means it's more forward. We're now looking at an area of water ahead of that edge of the sphere because we bent down and we're hitting the surface before we've reached that edge. So
okay, please finish the sentence.
So now to look up and see the edge, we need to raise how high we're looking so that curvature is now impacting that point, which means if we were looking in the same point we were before, we're looking beyond that.
Okay, enough. End. All right. You just said another ontologically absurd, ridiculous series of premises. This is what happens when you people don't study philosophy. This is what happens when you don't study ontology, which is a necessary prerequisite to physics. Look up the Wikipedia article. It's a necessary prerequisite to physics. There is no negotiable. It's non-negotiable. So if you're ontologically absurd, you have failed to successfully do any physical endeavor. What you just told me is that the line of sight is being, the line from your eyes to the horizon, right, is being distorted so that the distance changes. No, the distance, right? Distance is the amount of space between two given particular concrete concrete objects. The distance between your eyes or your head or your body, whichever particular component of your body you want to specify, and the horizon, which is supposedly the edge of the sphere. The distance can only change if the size of the sphere changes or you get further away from the sphere.
No, we're saying
No, I'm not done. No, I'm not done. No. That's how the distance changes. Anyone with two brain cells to rub together knows full and well that's how distance between concrete objects change, because there's more space between them. Not because the perception of the goddamn object in the distance is being distorted. Secondly, the line of sight is not a concrete object. It's not a concrete object.
I never said
neither is the length of changing. It's a detection. It's an empirical detection. Right? You're detecting light, which is emitting from the object. So no, it isn't the case that it is not the case that distortion of your eyesight is increasing distance. No, it is not. So your ontologically absurd breakdown is just that.
The point at which your line of sight is making contact with where the water.
What the hell do you mean contact? Do you believe our eyesight is a concrete object like a pole?
No, okay, contact is a poor word. I'm trying to like actually. This would be easier with.
So we are just seeing the object, right? We're just seeing it.
We're seeing a point. We're seeing a point on the surface. The point at the surface that curving line of sight meets, where it's like that is the point.
Curving line of sight.
What the
fuck? Curving line of sight.
Okay. Curving path of sight. If you don't like line because the lines are straight. Curving path of sight. Because do we at least agree refraction?
What the hell are you talking about? Curving line of sight, curving path of sight. Sight doesn't have a shape. The hell are you talking about?
What is it you think refraction is?
What is it you think the line of sight? What do you think sight is? Ask that question.
Okay, it's the light passing from some other location to your eyes, from some object to your eyes. Without refraction, that would be a perfectly straight path. With refraction, it's a curving path. Because it curves, if you're looking over the surface of the sphere, if it curves downward, the point at which that path reaches what we consider to be the horizon, that changes without the size of that.
Are you seeing light itself curve?
Path of the light curves, yes.
You're looking at light itself?
Path of the light curves, yes. You can see videos of that demonstrated on YouTube.
What you're talking about is when we see an object look crooked in some form or manner.
I mean,
right? The object seems to be crooked.
There are forms of distortion that do that, yes. There are things that also looming where it's raised higher than it otherwise would be, sinking where it looks lower. That is exactly the kind of refraction we're talking about.
Okay, so how is this sequitur with your conclusion? What is the logic sequence?
When you have downward refraction, it is looming things in the distance upward. That means that the
so begging the question that this is happening on the sphere, right?
This is the explanation for why the distance to the horizon changes.
Right, an a priori appeal to refraction, presupposing that you're on a ball when this happens.
Okay.
Fallacy.
So you have decided to believe that
distance invokes geometry.
What I empirically detect. I've decided to believe what I empirically detect. So I have not chosen to believe that the Earth is a ball, which I have not seen. I've chosen to believe that the surface of the Earth is a flat plane, which I have seen. That's what I'm doing.
Okay.
Distance invokes geometry. You are therefore saying that the horizon we see is the geometric horizon.
No.
When you've previously said that we don't see the geometric horizon. So which one is it?
No, I've never said it is the geometric horizon. The geometric horizon would only...
You've invoked it by saying distance to. You've invoked it by saying distance to.
There is a point on the surface we're seeing that there is a distance to. That distance
that would be geometric. That would be geometric.
The distance isn't changing.
Absolutely not. Absolutely not. Because the path of the light that's coming to our eye is curving.
The distance is not changing.
The distance to the point that we call the horizon is changing.
No, it's not. The only way the distance to the horizon, aka supposed Earth curve, could change is if the Earth is growing or we are moving away from the Earth.
Nope. A constant size.
What kind of fucking sense does that make?
Because if the light is curving, that has the same effect as if the light.
It's just you detecting the object.
The geometry of this is very clear if you stop and actually look at it and think about it.
No, you seeing the object is not an instance of the object going away from you or coming close to you or moving.
The object is not moving.
Optical distortions is not an instance of distance change.
This is not the object getting closer or farther away. This is you seeing a different location on the surface. The light refracts downward, you see a farther away.
So begging the question that this is happening on a globe.
I'm saying this is the explanation for why we see what we see.
Right, an a priori appeal, ad hoc a priori appeal to Snell's law, which you misapply here.
I get that you believe that. Now you're saying that the black swan.
So here you go, finna go to the circle again.
Refraction.
Because the game doesn't work on me. We're gonna go to the circle again. All right, so go ahead, go to the circle again.
Okay.
Let's go to this circular debate with you yet again. Go ahead.
You're basically saying that the distance to the horizon can never change because refraction does not extend.
Doesn't change the distance between the objects. Yes.
It's not changing the distance of the object. You're seeing objects that are farther away.
So it's not. Let me hold on. The distance between the objects are not changing. The distance of the object is getting farther away.
No. You're seeing different location farther away with different objects.
A different location farther away. So the Earth is growing.
No, it's not.
Right, the part of the Earth that's behind the Earth curve, it must be growing. Or it must be flattening out
in its
somehow.
actual location. Yeah, that's right. Are we seeing it in its actual location?
If you're seeing, do you mean, are we seeing it at the angle it's actually at? No, we never are, because refraction is changing that angle. Are we seeing
so this refraction that you're appealing to, there's only one medium, not two, and the density gradient is vertical, not horizontal. Your appeal fails.
You're wrong. I'm just sorry to say you're wrong, because this is how we apply it.
You're wrong. Given my specific objective premises in my refutation. Not an unjustified negation retort like you just saying, you're wrong.
Did I ever get around to posting that definition? Oh, I think I didn't hit enter. Okay, there we go. Anyway. Sorry, just reading something in a different thing here. Okay, so we're not going to agree on this. You have a very different understanding of Snell's law than engineers who actually work in optics do. You are going to believe that I'm completely wrong about that. We're probably just going to go around in circles on that. So,
ProtoThad, fuck you.
I'm sorry.
I won't say all that, but
I was hoping we could stay a little less heated than this and
move
on.
With your, well, you're not an engineer, so you couldn't say shit. Well, then you should shut your incoherent pie hole then. How about that? Stop flapping your guns then, because you're not one of them. There you go.
And your cavil must necessarily...
See when the shoe's on the other foot, you don't like that shit? You don't like it, do you? Fucking weasel.
And your cavil directed to us necessarily applies to physics classroom and Britannica, which of course were authored by specialists in the field. Okay.
Okay.
So you act as though specialists in the field know better, but it was specialists in the field that are saying what we just said about Snell's law.
Right.
So you must have this in-house disagreement about this doctrine.
Snell's law, you absolutely.
I suppose.
A classic example of applying Snell's law. You have, like, say, a lens that's made of glass. You have the air. You have very discrete boundaries.
And what
Still
has
can apply Snell's law to
what
gradients.
Snell's law has
that is
to
a more
do?
advanced,
What
that is a more advanced application of Snell's law, but it is absolutely a valid application.
More
of Snell's
advanced
law.
application of Snell's law, even though there's only one medium in your hypothetical.
Yeah.
Not two.
You treat same materials but with different densities.
He's trying to put lipstick on a pig.
That's explicitly what Britannica and physics classroom said.
This fucking wizardry that he's trying to pull off right now, and so that somebody can probably say, "Man, he might have a point." That's why it's like, you know, I'm treating like fuck off. You know, like you don't know if you weren't able to refute Snell's law.
If you read a little bit farther, you'll find the sources.
Why are you
that talk about?
You're not refuting ProtoThad. You're not refuting Snell's law. All we hear is you gish galloping off to another point, which is
I'm not refuting
some other bobblehead that I know of is refuting the fact that Snell's law is actually that, because we've got a more advanced knowledge of it. And it's like you don't say shit. You're not saying anything. You're not refuting Snell's law on its face that is two contact immediate. So this is the hill that you die on right now, right here. Your 35 years of fucking navigating the earth is just gone in one fell swoop because you can't understand Snell's law.
He died on two hills at once. Not only does he not have the conditions required to invoke refraction, he also doesn't have a geometric horizon to refract.
And when you teach
so your appeal to try and refute the black swan failed, even with the adjustment to the supposed paradigm that you really do use, supposedly.
So basically, you're coming to the black swan must be right because atmospheric refraction.
No, what we're coming to is a sunken cost fallacy for you. This is what you have right now. It's a sunk cost fallacy. There's nothing else for you to do but just to admit defeat, which you won't because you're 35 years into it. So you might as well just fucking go all in. You just got to go all in. Full cog this, man. Refute everything. You might as well. You might as well.
I'm afraid we'd get off kind of mired in some of these side quests here.
The mire that we're in right now is your horse shit that you want to spout off as refraction, which it is not. And it's, going flying in the face of what actual definition of Snell's law is. That's the fucking mire we're in right now that you can't get out of. You know that? Or are you not paying attention?
So with that being said, let me just say this. Y'all bless you and may y'all have mercy on you and get you out of your sunken cost fallacy and come to a whole knowledge of the truth, not just about the cosmos, but about the true way of salvation from this perilous world, which includes all the deception which you are currently stuck in. And with that, I'll take my leave.
I was gonna say I appreciate the positive sentiment. I want to say that even though I know we fundamentally disagree, I appreciate you guys talking about this, and I'm sorry we got kind of heated.
Sorry, but it's not a disagreement. It's a rejection of truth, which you have. It's a rejection of the truth, which you have. You're rejecting the truth. This isn't a disagreement. This is a right and wrong scenario, which we are right and you are fucking wrong, like to the 10th degree. You are so wrong. You're not only wrong, you're so wrong.
If that's the case,
it's the rejection of truth. So thank you for rejecting the truth. But what else?
Why am I able to get correct latitude, longitude coordinates, correctly applying measurements?
You can superimpose. You can superimpose any fucking thing you want on top of this flat and stationary plane and call it Yankee Doodle Dandy, and then say that you just came up with a new idea, because that's all you got is this fictional idea that you live on a spinning globe Earth because your math works out. Who gives a shit? Did you go and verify that shit? No, you're just talking about, well, it works out on a piece of paper or my computer screen or in a math formula. Like, so what? It's just not what the reality is. Therefore, you're rejecting the truth straight out, well, as we pointed out. And you're
Just
also
real quick.
Snell's law.
Just
Go
real
ahead.
quick. Just real quick. ProtoThad, from me to you. Come back, and it was my pleasure.
Yeah, from me to you, ProtoThad. You respawned retard. Go back to romper room, you fucking clown. God, he was vanquished about a year ago, Miggy, over on Nathan's channel. He's now respawned.
Oh, I was glad to have him in here because he needed another shellacking from the 24/7 crowd, at least from this group. But he's, I don't know. It's so bad, QE. I mean, it's just so bad. Oh my God! I was like, who is this? I haven't heard of him. I didn't even know he was like. What rock did this guy come out from under? Because what the fuck, who's ProtoThad anyway?
He's the one who's educated Herman Munster, McBugger Eater, on celestial navigation.
Oh, this is the guy?
Yeah, and Bob's whore, the science guy, Bob. Yeah, he put a little feather in their ear. He thinks he's all that in a bag of chips. This fucking guy couldn't navigate out of his own bathroom.
You're so right. You're so right.
You're a fucking clown, ProtoThad. What are you doing respawning back here?
I was going to say, QE, have you guys managed to demonstrate
Shut the fuck up. Go sell that shit to, like, third graders, and they'll laugh you out of the classroom. You're a dumb fuck. That's already been proven. I'm not doing it again. Bye.
A weasel of epic proportions, man. I haven't heard him. When he came in here, I was like, what the fuck am I listening to? And he sounded like one of those fucking weasels that you just want to like shellac. So I was like, I just want to let him speak just a little because I haven't heard of him. So when he came in here, he was talking high and mighty about celestial navigation and how he worked it out that the Earth is curving. What the fuck is going on with these guys?
He doesn't know what an elevation angle is or a triangle. That's what the problem is.
And it became clear as day as soon as he started talking his horse shit it was talking about.
Yep.
He says he doesn't need the Earth to be a plane in order to gain an elevation angle.
Well, he doesn't know what an elevation angle is then. Yeah. What's an elevation angle? Somebody define it.
You should hear him talk about Snell's law. Oh, it was so good.
John, you came out with the Black Swan 2001. Is that true?
2000.
Yeah,
2001.
2000 to it doesn't matter. Let's say it's outside like let's 2-3 years, and we know the argument. We know that it's horizon. And because of that horizon, we know it's not only horizon, that water, it's physical and making the horizon together with the sky horizon. That means the water is physical. I don't understand why people, Globers, coming and keep speaking about light, because that didn't change the physicality of the water. What is the distance? 6 miles and 9 miles, and behind, let's say, 10 meters behind the second oil rig, there is a water. That means whatever light is doing, we cannot see that water if we are on a sphere. Does that Globers can understand that?
Bro, Sasha, fucking Snell's law fucking singed his short hair like clean off. He was dead in the right when he started talking about that, he was dead. It was just it was game over.
Look
right
at this. Even there, you will say 2 millions, but doesn't matter what is going on Black Swan. You have the ocean. You see the ocean. You don't have that phenomenon that you know. Oh, you need to speak about Snell's law for 1 hour. No, no, man. You see the ocean. You don't have phenomena. You have phenomena on Black Swan refraction. You have some phenomena on the top of the crane. You don't have phenomena on the water.
And then his citation was some fucking random guy. It was just he pulled out of his ass and then he put it in the live stream, voice text. I don't know. You might see it. It's somewhere there.
Bro, how much refraction do I need to get my super glued fingers unstuck?
Did you get him stuck? What the hell?
Well, yeah, I mean, I heard refraction fixes everything, so I was thinking if I put some on my fingers, the glue will come out.
You'll need some gravity to go with it.
Hey, QE,
Remember?
I like that show today. I was listening to it circling around trying to pick up my husband from the airport.
Ah, yes. Yep. We got a
Might as well go.
treacherous,
Might as well.
treasonous traitor exposed.
Yeah, we might as well give him refraction, right? Because that's what we're in the habit of doing now, is it? Just giving them things.
I guess that's
Beg
another
the
topic.
question
We're
on.
still on refraction. I thought we were on the treasonous traitor. I thought we moved on, but apparently not.
Yeah, we are. Yeah, we are on that. I'm just saying, if we're going to give them, a presupposed radius of a presupposed ball, we might as well give them refraction too, eh?
Dude, imagine having a refracted radius. Mm.
All right, since we're all on refraction, what did the numpty define refraction at? Just kick him. Just put him in. Just kick him out of here. Do something. Somebody do something with him. He's not speaking while I'm in here. That's for sure. So, Maggie, what did he say refraction was? Since we want to stick with refraction.
I got my iPhone, but it's somewhere in the chat. Can somebody pull it up? He had cited someone, and it's definitely not Snell's law. Like, can somebody pull it up real quick on live stream voice text? You have to scroll up a bit, I guess, if we got lost in.
Yeah, there's too much, man.
There's a lot of shit in there. But he was talking about some other numpty that he was mentioning. That he says we have a more advanced version of Snell's law.
Version.
Which I was like, what the fuck? There's levels to Snell's law. What the fuck are you talking about? Yeah, it was comical to me.
Yeah.
And he pulled this other guy, whatever he was saying, out of his ass, because I know he didn't know.
Right. So in a medium where there's infinite variability of gradient density, you'd have an infinite amount of points. So it's impossible to preserve the normal line. So essentially, you can just make up any path you want. And as long as you can get it to balance mathematically, you can then, in their view, just claim that that's the path the light took. You basically just draw squiggly lines on a piece of paper and then say, yeah, that's the path the light took.
I asked him for a citation of refraction with the propagation of radio waves, and he posted that. What I just posted in the live stream voice text, that's what he posted.
Yeah, so just for the record, that's what Walter Bislin did to try to defeat the Black Swan. He just drew a bunch of lines on a piece of paper and then, essentially applied them in a ray tracing program and forgot that the light rays flipped over each other, so the image would be upside down. Hey, there's no predictive model of refraction for the globe. It's all post hoc.
There's no. It's already defined. Snell already defined it, so they got nothing with their fairy tale atmo. Their atmosphere, it's a paradox to begin with, but they got nothing. Zero.
What really drives me insane is that it's already defined. They act like they can redefine it just during the debate, as if it is even a debate, and then act like we can't understand what it is when we clearly do.
He had the audacity to say, "Well, the way you guys are misinterpreting it." How the fuck are we misinterpreting it? We just read it verbatim to your dumbass. Where the fuck is it misinterpreted at? Fuck, dude, that was annoying. He kept going on about saying that. You guys are just misinterpreting. I'm like, where the fuck are we misinterpreting it? Point it out. Refute that shit. And he did it. He was like, well, we got some other guy over here that's, we got a more advanced version of Snell's Law. Shut the fuck up, dude.
Yeah, we got some obscure black and white text from a no name on the internet that I just Googled.
Yep. I've seen some comments from Roofy. Was Roofy in? He must have been in. Was he in the VC?
Was, yeah.
Yeah, no, he was in here, though. He was cheerleading ProtoThad. You know, they get their champions, they all rah-rah behind when they're in here.
I seen him post a comment to Heretic, and he said, "So you deny the definition of Earth?" And then I posted what Roofy said of definitions. They're fucking meaningless. That's what I'm saying. They're abject retards, right? They contradict each other. They contradict themselves almost within the same breath. It's like it's like dealing with my sister's kids.
Right, they got one finger unstuck with minimal loss of surface area.
I had this kind of like this feeling. I was like, I bet you anything, QE he knows this guy, because he doesn't sound like your regular
Oh,
crayon.
dude.
He doesn't sound like a regular.
We named a whole logical fallacy by him.
Yeah, there was a logical fallacy named after him.
No kidding.
Yeah, I think AI was the one who named it after him, if I'm not mistaken.
You are correct.
I can't remember what it was, though. It's been too long.
Well, we called it the proto error, but I can't remember exactly what it applied to.
Yeah, you'd have to go back to that video, and I don't think Nathan titled his videos at that point in time. So,
But the general premise is that so you have a set of situations where there's a known error that's going to express itself down the line. So you have a plan for how to handle it when the error presents itself, right? Which admits you have an error. And it had something to do with obviously it had something to do with celestial navigation or something, but I can't remember exactly.
No, he fucking died on Snell's Law. That's where you're not leaving this fucking hill. You're dying right here. Fuck that. I was pissed. I was like, we're talking about this every fucking day, and so he went off about some advanced version of Snell's Law. Shit, what the fuck are you talking about? Where? Who said that? And he pulled that other guy, I'm on my phone right now, but I'd find where he cited this idiot.
it doesn't even make sense, though. A more advanced law? What the fuck?
Yeah.
What the fuck does that even mean?
Well,
it's stupid. It's just the Elmer Fudd sophist attempt to fucking to prove something they have they're village idiots. All of them. They're fucking fake intellectuals. Every single last one of them. ProtoThad, he's an actual retard. I mean, he's retarded. A more advanced law. More advanced law. That's pretty funny.
Yeah, you're laughing. I was laughing my ass off on my way home because I was driving. Why is this fucking clown? What the fuck?
What did I miss, brethren?
you missed ProtoThad coming in here trying to pretend that him and Dogs Are Gods are friends.
Gregory was in here giving him like at least a little bit, but I lit his fucking ass up on Snell's Law. Like he was trying to get away, talk about some other advanced version of Snell's Law. Like fuck you, refute Snell's Law right the fuck now. Like I wanted him to, and he just didn't want to. He was like, no, well we got fuck you, refute Snell's fucking law, dude. Like what the fuck? To contacting me, like he did want to do it. I was like, this is the fucking hill you down, you weasel. Like you ain't. Fuck that. Nope. Not today. Yeah, you bit off more than you can chew, huh, Proto? You thought it was going to be an easy win. Fucking weasel.
And Mickey, if he tries that, if somebody tries that again, just ask them this question: how do you preserve the normal?
Oh shit! No,
For
do I
real.
dare go down that road with this guy? I sailed the ocean waters for 30
What's
years. I know what I'm talking about. Shut the
yeah, but
fuck.
what's the normal, right? In Snell's law, it's the 90 degrees that they measure the angle of refraction, right,
Oh yeah,
off of.
he doesn't
So
know
if you have
angles.
a discrete, yeah, but think about it. If you have a discrete boundary between two media, right, then you have a plane of which that angle can be measured. But if it's just a mishmash of infinitely variable density, essentially, where's your normal biome?
AI. He said that the from the ground position from the GP of a star to the observer, the angle that the observer is seeing the celestial body, both of those lines, the connecting line from the observer to the celestial body and from the ground position to the celestial body, are parallel lines. Are
So,
parallel fucking lines, dude.
so
That's what.
what he's fucking actually saying is the hypotenuse and the adjacent are parallel
Yeah,
lines.
that's. I couldn't believe I was like, and he sailed the ocean waters for 30 years.
Yeah, he's a fucking clueless clown. Yeah,
Wow.
he didn't. He's down in his mother's basement.
I mean, that's the only thing I can think of, man. He's got videos and shit, but like, I don't know, man. I don't know, dudes. Like,
Hey, he draws circles on globes.
What is your profession?
See, old friend, I brought more soldiers than you did.